Welcome to the Paris MariaDB Server Fest 2020. Bienvenue à Paris. Willkommen nach Paris. I'm looking forward to 3 days devoted to users of MariaDB Server, the open source relational database management system, which is a fundamental building block of the Internet of modern applications on-prem and in the cloud. The conference is hosted by the MariaDB Foundation, a non-profit that promotes the openness and adoption of MariaDB Server. This is the moment that we've been waiting for. It feels good to stand here in front of a big crowd. That's what I would say at a face-to-face conference. Now I'm sitting in front of my laptop in Grankulla, Finland, but I'm still excited. So what I'm excited about is to work on the adoption of MariaDB Server with you, the database administrators, the DevOps, and the developers of applications based on MariaDB Server. In our previous conferences, we've been working on code contributions from those developing MariaDB Server itself at IBM, Microsoft, Alibaba, Tencent, and our other sponsors on top of the MariaDB Corporation roadmap. So this is a virtual conference, and we have a couple of innovations for you based on attending other virtual conferences the last months. First, we have the conference 3 times in 3 time zones so that you can attend it during your daytime. We have material for 2 long days, but we've decided to spread it out over 3 days so you can get other things done. Second, we have pre-recorded the presentations. This makes timing easier and hopefully sound quality better. And it makes subtitles possible, which should simplify understanding of both native and non-native accents. Third, and most importantly, interactivity over Zulip chat. The presenter is available with full attention to take questions throughout the presentation. Read our Zulip instructions on mariadb.org/zulipfest. It should be less than a minute for you to set up a chat account and then join the MariaDB Server Fest stream. The stream then is separated into 1 topic per presentation, so you can chat freely on a topic even if the next presentation has started. I'm excited to see how this works out. So whenever you have questions, ask us on Zulip and look at, if all else fails, look at mariadb.org/fest2020. That's where we've collected what should be important at this very moment in time throughout the conference and through all the venues. But let me now turn to the detailed agenda for today. It's color-coded with different colors for not different tracks, but different types of presentation. So the first one here is yellow, and that stands for use cases, user presentations. The first presenting company is Supermetrics, Dulipa Vijayawardana and Victor Djupsjöbacka. They will have a bit of a fireside chat telling their story about how Finland's hottest startup, Supermetrics, picked the perfect database or are picking the various perfect databases for their purposes. This is called Supermetrics and the Many Bears, a modern-day fable on the search for the perfect database. And as I said, they will be available for chatting with you and answering your questions throughout the presentation itself, but at the end we will have a Q&A session with the highlights and perhaps a couple of other questions as well. After that we have a gray presentation. Now gray is directed at the community also of the developers of the server itself. So this is somewhat akin to what we did in our unconferences. And this is an exciting presentation by the chairman of the MariaDB Foundation, Eric Herman, who's now working on the foundation for public code. He'll tell you what that specifically means, but it is sort of government-based open source collaboration between different levels of municipal and state level governments, mostly in Europe. And that's an ecosystem where you have developers, quite like we have in the MariaDB Server community, and he will compare how these communities work. An exciting presentation. Then we come to a blue coded presentation. Blue stands for functionality, and the functionality here is analyze. So it's about how the optimizer works, and the presenter is nobody else than Sergei Petrunya from St. Petersburg, who will look at analyze for statements. He thinks it's a hidden gem of MariaDB, and it helps you have a better relationship with the MariaDB optimizer to get quicker response times and more performance. And the next one is again a gray one, so it's a bit focused on those sort of taking part in the development of MariaDB Server itself, but this time when it comes to QA, quality assurance. So let's say you find a bug in MariaDB Server. How do you report it so that the developers can have a standard chance of fixing that bug? This is the topic of Sanya Alexander Bielkin, how to get your bug fixed fast. Then the color becomes green. So green is for best practices. The first one by Valery Kravchuk is almost a feature talk, so it could also, in that sense, be a great talk. So this one is about new features in MariaDB 10.5 for troubleshooting. So how do you, which features do you use in order to find the bugs that create performance issues or other issues in your application? Not the bugs in MariaDB Server itself, but the ones in the surrounding setup, application, configuration. He will have a second talk as well. That's about dynamic tracing of MariaDB Server on Linux, problems and solutions. And this was the hit of FOSDEM in Brussels in February this year. So I was at that conference, and the atmosphere of that particular presentation was really, really vibrant, because you could see people who had suffered from the difficulties of profiling their application and understanding where response time was being spent in production, because you can't really simulate issues that happen very seldom in laboratory conditions. So you need to do some instrumenting in order to find it out in a more realistic environment. And there are tools for that, and Valery knows those. Then we will go for another yellow presentation. This is Li Xunpeng, a user story about migrating from Oracle to MariaDB. Now, MariaDB is often compared to MySQL, that's fine, but don't always compare it to MySQL or Postgres. Compare it to Oracle, because the old truth that you don't migrate systems is old, it's obsolete. It used to be the case 5 or 10 years ago, never change a running system. That's what people exactly are doing these days. They are migrating to save cost from proprietary systems, with Oracle probably leading the pack. So some experiences from such cases is important at our conference. Then we have another blue one. So this is Seth Shellnut talking about MyTile, a cloud-native storage engine based on TileDB. So the storage engine architecture is what separates MariaDB from many other databases, meaning that the top level layer of the syntax of MariaDB is the same protocol, the same syntax, but the underlying storage can differ so that you can optimize your work for the particular type of workload that you have. And this is one case in point how MyTile works. The first day will then be concluded by another green presentation. It's about IT operations on Azure. with MariaDB, of course, by Ram Sajja. So this could also perhaps be a yellow one. It's a war story. It's a use case of how to migrate your application from on-prem to the cloud, in this case with Azure. And that concludes day one. I will be back with you tomorrow morning when we start day two. Thank you for me, and now let's get the MariaDB Server Fest 2020 in Paris going. So now for our first set of presenters, Gulipa Vijayawardana and Victor Dupshebakka with Supermetrics and the Many Bears, a modern-day fable on the search for the perfect database.
Welcome to Supermetrics and the Many Bears, a modern-day fable about searching for the perfect database. So this presentation from us is kind of a bit weird to do, right, Victor?
Yeah, COVID and all that.
Yeah, I mean, normally we'd be in front of you in an audience, you'd be looking at us, you'd be waving at us, you'd be giving us questions and things like that. We can't do that. We kind of broke into our actual office and are presenting this to you together so that we can have a conversation with you about looking for the perfect database in our organization and some of the stories and the problems we had. And we'd love for you to ask questions of us afterwards so that you get the most out of this. But certainly we decided that the story format was better than trying to have lots of screens. So the deck itself is fairly short, but the conversation we're going to have is going to be much longer. And obviously it is a bit strange talking at our computer screens rather than to you all. So if we stumble, we'll probably pick each other up and go on from there. So first of all, I'd like to introduce myself. My name is Dupes. I have a very long name. I'm a software and data geek, and I started out started out a very long time ago, but I worked for a company called Bioware, and then from there to MySQL and Sun. And then I started my own startup, Empire Avenue. And then somewhere along the journey, I discovered this incredible startup that our CEO, Mikael, had started and joined the company about 3 years ago here in Finland. So we are presenting this to you, the depth of the night in Helsinki, Finland.
My name is Victor. I also have a background as an entrepreneur and a software developer. And I've been at Supermetrics for about 4 years now. And the hair has grown about the same pace as the company, as you can see from the old photo.
And actually, when I started, we were about 9 or 10 people. You had just started 3 months before that. And now we're in 3 countries and 120 people and an amazing growth story and one of Finland's incredible growth startups, if not one of the fastest growing companies in the Nordics. So with that being said, Victor, why don't you give us some information about Supermetrics?
Yeah, so a quick intro to what we do. Basically, we bring data from one place to another, and that sounds very, very simple, right?
Extremely simple.
But the reality is not that simple. It's a lot more complex than that. We integrate with over 60 different platforms. We call them data sources. So mostly in marketing, but also from basically any area. We fetch data from these data sources, process them in our backend, store some data in different types of databases, and push the data out aggregated to different types of tools where our customers do reporting. So typical use case is the spreadsheet tools, Google Sheets and Microsoft Excel, very popular. Data visualization tools, but also data warehouses, especially for the bigger enterprise customers.
Now, you said store data, but in most cases, do we actually store data or?
Yeah, well, a lot of the processing does happen in real time. So we do store some data, but that's mostly for caching. So it's the typical situations we fetch most of the data actually from the data source in real time. And that brings some interesting challenges.
So you can see some of the numbers there. There's like terabytes of data being transferred, millions, hundreds of millions of queries, or 75 plus million queries, and something called 3 billion query seconds. What is a query second, Victor?
By query second, we mean a query being processed on a server for 1 second.
Right. So what does that query processing look like?
So here's a simplified overview of what our application looks like. It's a pretty standard setup, actually. We have requests coming in. We put them in a queue. We have workers picking up jobs from the queue. We go to the data sources to fetch the data, and we store that, as I said, in different types of databases, depending on the use cases. And we'll dive more into those different types of databases in a while.
Right, and of course, when we talk about storing, we're always talking about caching in many cases. But of course, we have some data sources where we have to store the data for a longer term cache or a longer term amount of time.
Yeah. So, for example, in some cases, the data source APIs don't provide the type of reporting APIs that we need to gather the data in real time. So in that case, we basically need to fetch raw data from the data sources, store it somewhere, and do the aggregation on our end.
Right. And so the interesting thing about talking about this application is that, I mean, there's a pretty standard stack, as you saw, like a pretty standard tech stack of workers working on things, processing data. I mean, obviously, we can't get into the secret sauce of how all that happens, but in terms of applications, it's not that unusual. And that's actually one of the interesting things about this application is that we have many different types of use cases that we have to deal with. But I think if you want to look at our application as a kind of a mental picture, you could look at it from the perspective of Finland itself. So this is a beautiful country, and I hope after coronavirus is done with and COVID-19 is gone, you get a chance to come here to Finland and visit and come to our office and say hi to us, certainly. But we have in Finland we have something like 30 million lakes. I heard something like that, like a few lakes.
Maybe,
per,
but that sounds a bit much. But
okay, so
definitely more than 1,000.
Oh, definitely more than 1,000. Okay, so I think it's like in the 30,000s, 100,000. I don't know, but it's a lot of lakes in this country. It's beautiful, and of course, water flows from lake to lake, from river to river. And if you think about data as that water that is flowing across all these lakes and rivers through an application, then wherever data starts to collect, then it becomes a pool of water. Something that you have to dive into, you have to dissect, you have to figure out what's in there. And these pools of data become larger and larger in an application, and then they become a lake. And we all know that trying to cross a calm lake is better than crossing a stormy one. Yeah. Victor has to deal with a lot of stormy lakes when it comes to databases. So our landscape is filled with these kind of pools. And one of the interesting things, and we don't get into this in this presentation, is that when you look at any technology stack, we tend to look at data structures or databases, and these are from vendors like MariaDB or Google BigQuery or wherever. But wherever you have a bunch of data, that is in itself a database and can become a problem for us. And that could be a queue system. So just keep that in mind as we go through this, because it kind of feeds into all the different types of databases that we have. Now, we structured this presentation as a fable, and the fable that we chose was Goldilocks and the Three Bears, because the Three Bears were testing out all the different beds to figure out which one was the perfect bed.
Wasn't it Goldilocks who tested the bits?
Believe so. Actually, you're right.
But anyway.
But that's because the bears were sleeping in different types of beds.
Exactly.
Exactly. All right. So, fables aside, so where does Mama Bear sleep?
Mama Bear is the traditional relational database. So in our use case, this means a lot of MariaDB, it means some Aurora MySQL, and it means Google Cloud SQL. We're a hybrid cloud, so we use multiple cloud vendors and different solutions there.
So what's Mama Bear looking for, Victor?
Well, it's a typical startup scenario, right? You start with a small application, you build a proof of concept. Especially back in the days, the obvious choice for data storage was the relational database. And that's where it all began for Supermetrics as well. But we still use a lot of relational databases, and MariaDB in particular. And the strength there is obviously the ability to do table joins. There's the indexing, which we use very, very much to have performant queries. But apart from that, we don't actually use the more advanced features of relational databases that much, like procedures or triggers or similar.
And that's an interesting thing about us, actually. We use relational databases, but we don't necessarily use all the features inside of a relational database. But transactional ACID-compliant data is very important to us.
That's obviously very important, yes, for the core application data.
But relational databases have had a problem with us as well.
Yes. As I mentioned, started out small, yes, that's fine, a couple of hundreds rows, maybe a few thousands of rows. But then the business grows, suddenly there's millions of rows, we add new features, joining tables, can be dozens of millions of rows. We do a lot of inserts, we do a lot of updates, a lot of deletes.
Lots of replicas.
And especially traditionally, the use cases or the type of things that we did wasn't necessarily optimized for relational databases. So other types of database solutions might have been better options there.
And of course, other problems with relational databases for Supermetrics has also been we may have databases in different parts of the world. They're not necessarily distributed, and it's hard to deal with multi-master systems and things like that. So management of those kind of systems can be a problem. And then if we go into some of the vendor locked-in solutions, such as AWS Aurora or Cloud Spanner, then, well, we're vendor lock-in.
Hard to be hybrid cloud then.
Yes, hard to be hybrid cloud, and you end up optimizing for each of the cloud vendors that you have, which isn't necessarily where we want to be as a company. So
that's Mama Bear in a nutshell. What's Daddy Bear then?
Oh, Daddy Bear. Daddy Bear's a simple kind of guy. He doesn't like this SQL stuff, and he thinks that we should just be able to get the data out of the thing. So Daddy Bear for us is Redis Enterprise, which is the enterprise commercial version of Redis that you get on open source. And I'll explain a little bit more about that later. We have Elasticsearch, and believe it or not, we have I'm going to consider Daddy Bear to also be our file systems as well. So
you're kidding, right?
Come on. Hey, you know the system as well as I do. So yes, EFS and Google Cloud Storage. Yeah, like I said, Daddy Bear is a bit simple. So yeah. So what's Daddy Bear looking for? Well, like I said, he's simple. He's not looking for relational data. It's NoSQL data, non-relational, very much key value systems or document-based systems. We're looking at documents or data sets that are 10 bytes to hundreds of megabytes or more. In our case, now each of the three main areas there, or four things there, kind of have a different use case for us. So, for example, Redis is very much our short-term caching solution in memory as much as possible. Then we have Elasticsearch is actually our metadata layer that we query for our logs and some analysis. And then we have our file systems. And the file systems is, well, there was a reason why we ended up in the file system. And that was because we were trying to store huge amounts of data into Redis. And I don't mean transactions into Redis. I mean like hundreds of megabytes of data into Redis, which...
Hundreds of gigabytes.
Hundreds of gigabytes. Wow, what's a meg? What's a gig? It all comes down to the same thing, right? So end up, we couldn't do that. But we needed to get this data back out. And so we decided to put it into file systems. It actually worked out really well, which is amazing. But of course, the speed is variable. Networking, file I/O, different cloud vendors.
Yep.
Yeah.
But it has its purpose for very big files.
Indeed. And we discovered the efficacy of that. Now, one of the I mentioned Redis Enterprise is because we moved from Redis open source to Redis Enterprise because there's a lot of things that gives us. And there's a story about all of this that comes back to MariaDB at the end of this. So Redis Enterprise gives us the ability to use SSD storage instead of memory so for large files. And this can be very useful in sub-second queries that we need to do. So, but we wanted to share some of our war stories, and one of the war stories actually was fairly recent, and I'm going to mention a few names in our company, Nicholas and Method. They had to mostly deal with this. In their situation, they were dealing with a data source where we did need to store the data. This wasn't a real-time data. We needed to fetch the data for customers. And when we initially did our tests and did the scoping and the specs, we found that it was small bits of data. We could throw it into Redis. I think that was
the natural solution for
absolutely
key value store.
Key value store. It makes perfect sense. In memory, we're going to do that. And suddenly we were doing a test run with actually, I don't think it was just a handful of customers. And suddenly that data set wasn't the 5, 10 megs that we were talking about, actually turned into the 50, 100, 150 megs, which...
Gigs again,
megs, gigs, you know what I'm talking about. And that can be a bit of a problem when it comes to memory and cost. And it strikes at the heart of a CTO's heart here. So what do we do? What did we do? Well, we had to think about it again, and we had to go from a non-relational database to a relational database. We actually had to rethink how the application was working. And this comes down to one of the problems with non-relational NoSQL data structures is that your application has to deal with that. And in our kind of analytical aggregated, where we're looking at data aggregations, sometimes that is actually not the best way to deal with it. And there is a good reason why SQL was created, and you kind of walk right back. So what did we end up with? We ended up with, in this situation, moving from non-relational to relational.
Back to MariaDB.
Back to MariaDB. We actually walked right back to MariaDB, which was entertaining in that we discovered a lot of ways of improving even that solution as well. So, with that being said, however, next up is
Baby Bear, last but not least. And here we're talking about the data warehouse type of storage. So in our case, a lot of Google BigQuery, but also Snowflake and PrestoDB. And if you're not familiar with Snowflake and PrestoDB, Snowflake is a vendor that provides a data warehouse solution that works across clouds. So at least in Google Cloud, AWS and Azure, whereas PrestoDB is an open source file-based
columnar stored database.
Yeah. Originally developed by Facebook.
Right.
But yeah, it's baby bear, but not a very tiny baby bear. So we're talking very, very big data here. But the key is that, for us at least, is that we're able to do able to use SQL.
Mm-hmm.
So we can do table joins, and we can still query a lot of data really fast as long as we do proper database structuring.
But it's not really suited for anything small, right?
Right. There's always a cost to everything, and in this case, both storage and querying can be quite expensive depending on the use case. So it's not the ultimate solution to every use case.
And of course, for us, BigQuery and Snowflake, these are potentially internal databases that we use for internal analytics and things like that. But for one of our scale cases, we ended up going with PrestoDB. And what was the use case there?
Yeah, so there the interesting case was blackout.
And this is what happens when we do this very late at night, kids. No, in this case, we were taking data initially into MariaDB.
Right, so we're working with MariaDB and hit the limits there. The queries were just too massive for MariaDB to handle. And at that point, I think it was Andy, our head of data engineering, who came up with the suggestion that, hey, let's try PrestoDB. It could be a better fit for this particular purpose.
And it was, from a cost perspective, from a ease of use perspective. I mean, we now query gigs. I think we actually query a terabyte of data in there somewhere, and has been quite effective for us. But of course it has its downsides. It is file-based. It does have limitations in changing table structures and things like that. It's
updating data is not really an option.
Exactly.
It's only inserting and deleting.
So there's lots of issues with each of these particular things. But
an interesting point here as well is that we actually use Redis as well.
Oh, right, of course. We couldn't actually just do it just against Presto.
Yeah, so to insert row by row or even like hundreds or a few thousands of row at a time wasn't really an option. We needed to first gather bigger data sets and then push them all, push all the rows at once. So we actually used Redis there for the gathering of data.
And that brings us to whether Goldilocks. See, I did get the fable right? Okay. See, eventually, right. So did Goldilocks find the perfect bed? So let me ask a question before we get into this slide and talk about this, Victor. How do we actually get our data into Elasticsearch, by the way, for our logs?
Yeah, so we push our logs from application level, but we definitely do not push them directly to Elasticsearch.
Oh, whoa. Why not? I mean, come on. It should be able to handle this.
Yeah, but then if Elasticsearch goes down for some reason...
Has that ever happened? Really?
Nah.
No?
Really.
No.
Then suddenly we're out of logs, and the logs are very important for us, so we can't let that happen. So again, we use Redis as an kind of intermediary storage there
Well, I think this is the kind of the moral of the story, though, in the end, right? So in everything that we talked about, I think this is where we also so here. So with some stories that we've talked about going from relational to non-relational, but in a lot of cases where we have actually gone from non-relational back to relational, as I've said in the stories. And part of that is we keep coming back to SQL. We keep coming back to the ease that we have with working with SQL, and it's like putting in an old coat, and you just feel comfortable in it, and it's easy to get going. So MariaDB in MySQL has been a constant feature in our lives. I don't think it's ever gone away, and in fact, we're expanding our use. Yeah. But more often than not, we end up with
one form of hybrid solution. That's usually where we get the most performance and the most cost effectiveness and so on.
So, and that's an interesting thing. It's like, so we kind of look at our data structure or the database for a specific part of our application not as one database, but as a hybrid database. One cannot exist without the other. It's not saying that we can just live with one, and sometimes it's three.
Yeah, it can even be all three of them. So, for example, having the final ultimate set of data in the data warehouse, storing part of it in a traditional relational database like MariaDB, and then maybe some aggregated data or very often used data in Redis for the more key value type caching.
And maybe that's the perfect solution. Do you think that there is possibly somewhere out there a perfect solution that we still haven't tried, or that we can use for our scale, like something that is globally distributed, data warehouse, columnar, maybe, or something like that, with a relational database as well, and some document or non-relational stuff, but also non-vendor lock-in across all our hybrid cloud solution. And what am I missing here? Oh, something in memory so that we can use it for key value as well. Like,
it sounds like a dream.
It is a dream. One that, I know there's a lot of people who've tried this, but yes.
To be honest, I don't know the answer to your question, but I certainly do hope that there is or will be. We've been following the developments of SkySQL with a lot of excitement, partly because of the multi-cloud and inter-cloud capabilities that you mentioned. We do use 2, if not 3 clouds, and we need to be able to have the data travel between these clouds. And if we do it ourselves, it means a lot of self-managed databases and a lot of maintenance associated with that.
And we don't have a lot of DBAs, though there might be someone watching that might want to come work for us, right? I mean, there's all sorts of cool things to do here, but I interrupted you, sorry.
Yeah, but no, we don't have like dedicated DBAs, at least not at this point in time. So one option is to utilize the very best knowledge and experience that there is out there in the form of Sky DBAs, and that's essentially a model that we have tried already with Redis Labs, as you mentioned, in the case of Redis. So using the enterprise solution for that.
And I think supermetrics is an interesting use case. I think it's something, and I'll be honest, when I started here, my first thought was, this is going to be simple. We're going to use MySQL, as we already have, MariaDB, of course, plus Redis. Everything's going to be simple. But in actual fact, as we have scaled and as we have grown, we have so many different use cases that like nothing works just as you would like in one single database. And that seems to be the crux of the matter. They always say use the best tool for the job.
Exactly.
And that is true. We can't seem to use the best tool for the job. We have to use the best 3 tools for the same job to do the same query. It is not a joke to say that our application sometimes in one code piece might query the Redis, the relational MariaDB, and the data warehouse type structure within a 20-line span, and combine those 3 things together to give back the data set that we need. And that's a unique point, I think, in some cases.
Yeah.
So.
Yeah, and that's something where, as I said, we're excited about the potential of SkySQL and also the hybrid aspect that SkySQL provides. But
the other moral of the story is, of course, is how important relational databases have become, even though we thought that NoSQL, SQL battles would be waging even now, and our lives would be more NoSQL than SQL. So
we still find ourselves doing a lot of table joins.
Yes, we do. Yes, we do. But hey, one of the interesting things, and I think time is getting pretty short here for us. So we do want to say that Victor and I are basically like the messengers of an amazing team at Simplimetrics. And I would be remiss to say that even these 5 names on this list, on this slide, is just the tip of the iceberg. Our thanks to Andy, Dimitri, Nicholas, Metod, Mikhail, and lots of other people. So, and by the way, I just want to put a plug in for Supermetrics and say that we are hiring, so please do check our jobs, but there may even be jobs that we haven't posted, so please do get in touch with us. Thank you very much to MariaDB Server Fest, to Anna, to Kai, to all the wonderful people there. Thank you for having us. It is very strange giving this presentation from this format. Victor and I, you're going to have had a lot of fun trying to set this up today.
Very fun.
So we hope you'll come visit us here in Finland, and looking forward to the questions, and we'll answer as best as we can. It was a pleasure, and see you next time.
Super presentation by Supermetrics. So thank you, Dukes, and thank you, Victor. I was following what's happening over Zulip chat, and people particularly liked the format where there was a replica or dual node setup between you two guys. So, and you got a couple of questions over Zulip, and some of them even were not got in a bit late, so that you can, as I understand, follow up after we do the live Q&A. So my first question on the live Q&A is about architecture. So you were talking about not just MariaDB, but other solutions as well, like NoSQL and key value store. So when thinking about architecture or your product, how do you parse the architecture? How do you decide which parts of your setup goes with which architecture?
So a lot of what we do is having data flow through our systems. So we cache a lot of data for shorter periods, and in that case, key value stores are an excellent option. So that's one thing. How long are we going to store the data? Obviously, the size of the data. When we're dealing with gigabytes and hundreds of gigabytes, SQL databases and NoSQL databases are fine. When we get into multiple terabytes, we're maybe looking more towards the data warehouse type of storage. And of course, the data structure as well. So if we see that we need to do, for example, complicated joins between data, then in that case, relational databases and the data warehouses that are SQL based are good choices.
And I can add to that by saying, from the practical perspective, what that usually means to us is we have to first starting off with the data source on the other end, then start the planning process looking at what data we're pulling, and then how the data flows through our system. It's not always easy, and we actually make quite a few mistakes during the planning.
It's a lot of experimenting as well, yes.
Yeah, and sometimes we don't have access to the customers and data, and so we spend a lot of time trying to replicate what our customers might be pulling in order to find all the different types of data pools. It's not easy, unfortunately. I think we're only scratching the surface by giving you this answer, to be fair.
Well, you mentioned data warehousing. I'm picking up one question that you got on Zulip. Did you have a look at MariaDB column store?
Well, considering I answered the answer on Zulip, no, we didn't. And to be fair, it's partly my brain is blanking on why we didn't. I know that we talked about it, but I think in the end we decided to go with PrestoDB in a very specific case. And I seem to think and remember part of it was a lack of ops expertise in managing a MariaDB column store at the time, and our ability to use the managed PrestoDB won over the use of the MariaDB column store. So it's one of the things that we look at when we're thinking about moving to SkySQL, for example, or SkySQL, is being able to use some of those managed services. Our organization really is about how we can leverage other organizations to help us get to where we need to get to, rather than always having in-house staff.
So you mentioned SkySQL or SkySQL. I also don't know how to pronounce it properly. In that context, what's the difference from your standpoint between SkySQL and MariaDB?
I'll take this one. A couple of different things. So MariaDB for us is the technology base, and that's same in SkySQL as well as in MariaDB org. It is a technology, and we use and run a MariaDB databases internally for all sorts of different reasons. The technology itself, great, fantastic. The other part of it is more of a business concern for us. As we grow the organization, as we grow more into enterprise, there are several things that we have to keep in mind, is our ability to support technology and making sure that we have round-the-clock coverage for any issues that happen and how that works out. It's a lot of people and ops considerations that we take into account, monitoring, alerting, all those things. But then we have data concerns, making sure that whatever technology we use is hosted in the correct regions, how we can manage those regions, how we can manage vendors. And then the third, very specifically and very important to us, is we want to be as cloud agnostic as possible. And that requires us to look at how we can leverage all of the three major, certainly the two major cloud vendors that we use to support our customers. And SkySQL then plays into that very much, both from a managed perspective as well as from being cloud agnostic.
And as we mentioned, we've pretty much done the same or similar move with Redis, and been very happy with using Redis Labs Enterprise. So yeah.
Good. Well, we're drawing close to our allotted time, but a brief question on technology. You could answer it for 1 hour, but you have less than a minute. JSON, how important is JSON for you?
Well, JSON is at the heart of all the data that we touch. Most of the data that we pull in from the data sources are JSON, and we store a lot of JSON. So yeah, it's a key format for us. We haven't actually used it that much in terms of the relational databases, but that's probably something that we're gonna use more in the future as well.
That's using SkySQL and MariaDB's JSON features are going to be crucial for us. as we grow.
Which also means that I will have to thank you now, Victor and Dubs, for a great presentation and good answers. Thank you, guys.
Thank you very much for having us.
I now have the pleasure to introduce you to the chairman of the MariaDB Foundation, Eric Herman, who will be talking about how to compare the ecosystems of MariaDB and the one of public code.
Hello. Today I'm going to be talking about comparing ecosystems, specifically comparing the ecosystems of MariaDB and public code. My name is Eric. I'm a developer and I have been for the majority of my career. My career has mostly been commercial, although I did work for MySQL from 2004 to 2009. But even during that time frame, a lot of the work that I did was on their commercial proprietary products. So even during that time frame, it was mostly commercial work that I did. That said, I am a long-time contributor to free and open source software projects. You will see commits in MariaDB, in MySQL, in the Perl interpreters, Perl core, as well as a handful of other maybe less marquee projects. I have been involved with the MariaDB ecosystem for a while. I've been serving on the board of directors since 2015. Currently, I am the chairman of the board of directors, so I'm serving in that role at present. Professionally, I work for the Foundation for Public Code as a code-based steward. In my role as a code-based steward at the Foundation for Public Code, I often point to MariaDB as an example, usually as an example to copy, a template that we should follow. But occasionally I talk about it as a counterexample. We don't want to do it like this. And so I'll definitely be highlighting some of that throughout the course of this talk. So first off, what is public code? Public code is the combination of software and public policy that is produced for and by the public. And as we think about it, software is becoming core infrastructure. We see cities collaborating in order to build the applications and services that are essential for them to execute their mission, whether that is allowing me to register for some form of taxation online, or it is for me to renew a permit or schedule a big trash pickup or anything. Many of the things that we expect to be managed by a municipality or by a larger public organization are now software. And very often public policy is being specifically implemented in software. So much like roads and water and waste disposal are all things that we expect public organizations to at least manage, if not initially, if not run the detailed execution of, software is also becoming core infrastructure. The Foundation for Public Code publishes the draft standard for public code. This is a document which collects the set of requirements that all the software that we depend on as infrastructure should measure up to. Now, if you're a professional software developer and you read through the standard, I expect you will find very few surprises. I think that everything in there is going to read to you like the typical best practice, mostly what you're doing today. If, like me, you don't have a deep background in public software development, then the first time you come across some of the things that are a bit more policy related, that might be new for you. But other than that, I don't think you'll be very surprised. At the Foundation, when we look at a code base, we look at it from the dimensions of quality, community, product, and support. And quality is what I do as a developer. I work with the developers and we take a look at the standard, we compare their code base to the standard, and we say, does it have the quality we expect? But a code base is so much more than just the code, and even more than the code and the developers. There's many more individuals that make up that community, and so it's not good enough to just stop there. We must have a view which is wide enough to encompass all the different people that are either deploying, maintaining, monitoring, running the software, the end users of the software, the citizens for which this software serves. So the community can be much, much broader than the developers who are making the code and the managers. And like commercial software, we expect that there's more than just code sitting in a repository. We expect it to have what's needed to get it installed. We expect it to have what's needed to understand how to run it, that it has the documentation and the other things that a complete product has that not all open source projects have. And of course, you may not be in a position where you want to or where you're even able to install, deploy, maintain the code base yourself, and you may want to contract out those services. And so is there a support network that's able to provide you the help that you need so that you can do what you need to do? And so those are the four things that we look at. And in our organization, we don't do advocacy. What we do is we work with code bases to make sure that they are achieving their goals in regards to these four areas, but we don't have to convince them. They're working with us because they're already on this road. There's other organizations that do advocacy. The Free Software Foundation Europe jumps to my mind as their public money, public code campaign. But the organizations that we work with, they've already decided to work in the open doing public code. When I think about the mission of the MariaDB Foundation, they talk about different pillars. They talk about continuity, collaboration, and ecosystem, which I already see some overlap, but one of the things that stands out is I think that they are a little bit broader. And then there's, of course, the mission of the MariaDB Corporation, as well as all the other big contributors that contribute to the MariaDB codebase, as well as all of us as individuals. We don't even have a mission statement necessarily. We're users of the product. So when I'm comparing MariaDB to the standard, or when I'm comparing MariaDB to one of the code bases that I'm working with, there are times when MariaDB has an obvious advantage, and that is that MariaDB has a gigantic ecosystem. There's all the work that's coming from all the developers employed by the MariaDB Corporation, as well as the engineering coming in from the likes of IBM and Tencent and Alibaba and everybody else that has made very, very interesting contributions over the years. And the user community is very large indeed. So we wouldn't expect that if you are a city developing a license renewal website, that even if you're in collaboration with several other cities that have a similar need, that you're going to have nearly the user base of something like MariaDB. We wouldn't expect that you'd have nearly the developer pool of something like the MariaDB server. So it's not always a perfect comparison, and that's not even anybody's fault. That's just because sometimes there's not a match. But one thing that comes up is, are we developing a reusable component? Are we developing software that is more than just going to be used in this one project that can be used in other projects elsewhere? Is it going to have a life that is bigger than this one instance? And this is a great place where I get to compare with MariaDB, because in the case of MariaDB, users start with an application, maybe with a WordPress site. They don't think to themselves, I want a MariaDB database. They may not even think to themselves, I want an SQL database. However, MariaDB is a component that is a default in many Linux systems or other systems. So that's a great example that I can point to, and I used recently when talking about OpenZoc, which is a case management component. And if you're a city and you're developing something which is going to have a case management aspect to it, you don't start by saying, I want this specific case management software. You start by saying, I want to deliver a service. But maybe you're delivering that service according to the Common Ground standard, which is it's a way to write applications that was standard described in the Netherlands. And the OpenZac component fits into that Common Ground standard. And maybe OpenZac becomes the default in that standard. And then anybody developing a Common Ground app maybe will naturally reach to OpenZac as the first case management component that they would use. So that's an example where I get to draw a very close parallel. Another place that I get to draw a parallel is that, of course, collaboration comes with a cost. There's, if nothing else, communication overhead in working with others. But I think about how MariaDB, the development started with one organization. Now we see development coming from many. Of course, there's the majority of development happening in the MariaDB Corporation, but we also see very interesting features coming from other places. And I think about the instant add column, which came from a brainstormed at MariaDB Unconference a couple of years back, and we had developers from Alibaba and MariaDB Corporation, naturally, and Tencent sitting together in a room talking about a way they could do this. And the prototype was actually developed by one of the Tencent developers. So that is something that benefits us all. And even though it was solving a very specific use case that they had, that's now something that benefits everybody. And so that's a great example and makes it parallel to one of the things that I see with the Signalen project, which started in Amsterdam, specific to their needs, and the Association of Netherlands Municipalities started working with Amsterdam in order to replicate that. And then, of course, they needed to change things so that it would be appropriate in some of these other contexts, in some of these other cities they wanted to deploy to. But those changes were also beneficial to Amsterdam. So yes, there's cost in collaboration, but then, of course, the obvious benefit is that the other developers are developing things that are not your highest priority, but you will benefit from. And the first thing that I do when I think about MariaDB and my role is I think about, so how does MariaDB measure up to the standard that we publish? Well, so does MariaDB code in the open? Well, the answer is yes. And when I'm talking to development organizations, especially ones that are just making the transition from working in private or behind closed doors anyway, working in a closed fashion, to wanting to transition to working in an open fashion, they are understandably hesitant about all of the things that can come up. And I get to point to MariaDB and I get to say, hey, they have their public development branches on GitHub. They don't just do a big release at version boundaries and say, here's all the changes since last version. Instead, you see the code unfolding as developers are working on it. And you know what? These developers make mistakes. It's fine. We're not going and pointing at them. We're not holding our bellies and laughing at the mistakes they're making. Instead, we understand that that's a normal part of the development cycle. We all make mistakes. Sometimes we make dumb mistakes. That's fine. They get discovered. We talk them through, and we come up with a solution which doesn't have that mistake embedded in it. And so that's something where, even though it's scary, we can see that these developers don't have to be afraid, because we can point to the MariaDB ecosystem and say, look at the work that's being done there. You don't see that there's really anything to be afraid of there. And it's not that all the code is perfect at all. And one of the things about working in this way is things that we might have been sloppy about, or it might have been just expedient to do something like put some secret data into the repository. Now we know that if we're going to publish this, we can't just, because it's easy or expedient, commit a password here. We have to have good hygiene, have our secrets in a separate location, not in the codebase repository. So there's a natural advantage that comes up that we want anyway. And then as we are working, if we're working in the open and somebody else is working on a long-lived branch or maybe a patch set, if we're working in this incremental fashion, it allows them to track our work again in an incremental fashion. And that allows us to work with a much, much wider range of vendors or contributors or individuals. And the standard talks about building reusable and portable and extensible code. And when I point to MariaDB, I get to say that these are aspects that have contributed to the fantastic success of MariaDB. No matter what operating system you're running, no matter what architecture you're running on, you can run MariaDB. But also, this is a bit of a counterexample because internally, MariaDB is not so modular. It's not so easy to reuse the bits and pieces. I'm not going to pull the parser out of MariaDB in order to examine the complexity or build a load balancer or something like that. So when I look for examples of systems that are internally well modularized and the pieces are reusable, I point to things like GNOME's glib, where projects that have nothing to do with GNOME are reusing bits and pieces of the glib libraries, or KDE frameworks, very much the same thing, where people who are writing things that aren't even intended to run on KDE are using some of the libraries that they developed to make writing KDE applications and writing KDE itself easier. And this lack of internal modularity is something that I think limits contributions. And I think that this is something that we as an organization, or as a community, as an ecosystem, I think this is something that we as an ecosystem, this is something that we should give some thought to. Is that a place we can improve? Something that's important for all open source code bases, whether public code or not, is that they welcome contributors. And if you are making the transition from developing in a closed fashion to developing in an open fashion, this is really hard. Part of why it's hard is that you probably don't have a lot of extra bandwidth for reviewing somebody else's contributions that are not in your highest priority things to do list. So you know that if you're working in the open, that you're going to have to invest in that. That takes a time commitment. And also, it's not a lot of fun to admit all of your mistakes in public, to have a public bug tracking system that anybody can look at and anybody can read and anybody can see. That's intimidating. And then we need to give serious thought to, okay, how is security issue reporting going to be? What's the right level of transparency for that? And then also, if we're making a public roadmap, which is important for encouraging contributions, because without a roadmap, it's very difficult for me to know whether or not I'm helping or whether I'm pulling the code base back in a direction it doesn't want to go. And so a publicly visible roadmap is useful to all contributors to know how their contribution slots in with the future as it may unfold. But a publicly visible roadmap also starts to feel like you're making promises, and you definitely need the freedom to be able to say, this is what I believe we're going to deliver, but this is not a promise of what we're going to deliver. And so articulating that well is important. So I think there's also room for improvement in the welcoming contribution of the MariaDB ecosystem. And specifically, what I detect is that there's a lot of undocumented tribal knowledge where all of us that are in the ecosystem have a sense of things that are not written down. For instance, one of the things I would like to do is I would like to get together with as many of the senior developers as I can get time with and get them to tell me what they hope to see change in the structure and the architecture of the code base. And then if I collect all of this together, maybe I can present it back to everybody and say, hey, is this our technical roadmap? So maybe that'll happen this year if I can get together with enough people and carve out enough time for that. Related to that, if I'm doing development, where are the engineering guidelines? There's a little bit on style, but in terms of really how one should approach coding, what's the right level of abstraction? When do I use inheritance? When do I use composition? How much should I be programming in a stateless functional style? When is it okay to manipulate as much state as I want? These kind of engineering guidelines I don't think that we have these written down. This is something that each developer on the server or in each of the connectors, this is something that they know, but is not explicit. So I think we could document that. And also, I think that we've not been good about what our feature roadmaps are going to be. But even though we haven't been good about this, this is still an area where we do naturally share it. Every time I'm at a developer meeting in an unconference or similar, the developers are always sharing what their challenges are, what the things they want to implement are and why. And so there is some knowledge about what is coming on the roadmap. It's just not written down. And so we do share this with each other. We just don't share it in a way that is very easy for people who weren't in the room to be able to learn. And so I think that this is an example where it's perfectly fine, but we could improve. Believe it or not, there's a bunch of code out there running in the world that is delivering a lot of value that is not under a version control system, that has backups with dates and times or version numbers in the file names, but is not in version control. Fortunately, version control is becoming the norm. I think especially thanks to GitHub and GitLab and the others that have made it so easy for those of us, regardless of how technical or not we are, to participate in the forking, modifying, requesting merges, seeing our changes get merged. So I think that these online platforms have made us all better users of version control system. So that's really good. And obviously, MariaDB is up on GitHub. It uses Git. If we go back through the Git history, not only do we see everything since it was transferred into Git, but we can also see the old Bazaar commits as well as the BitKeeper commits that stretch all the way back to Y2K. So that's a good one. I think that's one where we can show that it stands the test of time. And another thing that I work with all code bases on is to ensure that every line of code is getting reviewed. Every contribution, even documentation, everything should have more than one brain review it. That there's the author and there needs to be somebody that's taking a fresh look at it as well. Let's not have the habit, as convenient as it is, of having the developer write the code, test the code, commit the code, and deploy the code, and have no sounding board to give them the insight that they overlooked something obvious. So this is something with the MariaDB ecosystem that I see is basically true in practice, but we could do this a little bit better. Specifically, we could have protected branches or enforce it otherwise. And there's times when I see request for review happen when it doesn't happen in a timely fashion. So I think we could get better about our responses to that when somebody adds a pull request, although I really, really appreciate how much work that is. And hats off to the devs that are doing that review. And I do understand that you are each very, very busy. When I think about the reviews, another area that I think we can improve a bit is we typically review the code and the tests very closely, but we think of the documentation separate as an afterthought even. And so I would like to see us, when doing some code, to also conjoin that with, and this is the change that's needed in the documentation, so that it's a single unit. And that's a bit of a stretch for us, I think, but that is an area that I think other code bases do better. And there are standards that are relevant to the MariaDB code base, specifically the SQL standard, but also, depending on which connector you're using, maybe the ODBC or JDBC or one of the other standards. And so our reviews of these contributions, are they having somebody look at not only the code and the tests, but also, is this bringing us closer to the standard? Is this unrelated to a standard, or does this bring us further away from the standard? And so this is something that I think I think it's just a place we can improve. I don't think it's a big deal, but I think it is something that we are not making explicit today, even though I think it happens more or less as it needs to on an ad hoc basis. But I think we could be more deliberate about this. And the one thought I had on this is maybe a reviewer checklist would help. I don't know if it would or not, but possibly. And another thought I have is that we don't engage enough people in the review process. People who are not developers absolutely are good candidates for documentation because they will read it as a non-developer, which is fantastic. So let's engage in our ability to do documentation as well as code. There's a lot of code I can't contribute to, but maybe I can contribute to the documentation that is of what that code is doing. So I think that we can increase the pool of people involved in the review process. Now, obviously, if I'm only working on the documentation, I can only sign off on, yes, the documentation for this looks good. I have no idea if the code is well structured, but my part, the documentation looks good. Or, hey, I don't feel like the documentation explains something that makes sense to me. Maybe the code is great. So we have to be clear if we're only reviewing part of it, what role we are taking on in our role as a reviewer. Continuous integration is something that is important for every code base, and fortunately, due to I think largely we can give credit to the online repository hosting services like GitHub and GitLab and such. Continuous integration is becoming the norm as well, and MariaDB has had continuous integration for a very long time. It's had BuildBot since before there was Travis integrations and such, and BuildBot is continuing to improve. But it could be faster. There's often a big delay between when a branch is pushed or a merge request is opened and when we see the results of BuildBot. So that's something that could be better. Also, sometimes tests fail and then they get rerun and they pass. So there's been some unstable tests historically. I understand that that there's significant effort right now to identify and resolve all of the unstable tests. Maybe that's maybe that's done now. I don't know, but that's something that I think is something that needs attention continuously. Also, test coverage is something that we don't report in the MariaDB ecosystem. So it is possible to run test coverage utilities, but we don't currently. And as a reviewer, when I'm reviewing code, I want to be confident that the code doesn't break anything, and what I'm reviewing is the structure of the code, is the clarity of the code. I don't want to have to, as a reviewer, try to be a test engine in my own head, imagining every corner case and branch condition. I would very much like to have the test suite give me confidence that the code works so I can focus on, is it well implemented? Many code bases are doing now is they're saying you can't merge to the main development branch unless all the tests pass. And that's something I would like to see us be able to enforce in the MariaDB server code base as well, which we don't today. Documentation is an area that I think we can all participate in. So please contribute. The Standard for Public Code says you should document your objectives. Well, that's something that I think we do a reasonable job at. I think we could be more explicit about that, especially around which versions of the SQL standard and especially around to what extent we expect this database to work as an upgrade path from another database or similar. Document your code. Again, I think that if you're a developer, you're already doing a pretty good job of this. Obviously, this is something that I think few of us would say the documentation across all of the server and all the connectors is as good as we'd like it to be. So I think that that as you're working on code, also take the time to contribute to the documentation there. Use plain English. This seems really basic, but remember that not everybody reading the code is necessarily going to be a native English speaker, and therefore the documentation, whether that's in the code or on the website or anywhere the documentation is, please do your best to write it as simply and as clearly as you can. And the goal for the documentation should be to communicate. We don't have to show off how poetic we are. So anyway, use plain English, please. And I would say on the whole we do pretty well here, although I think I would like to see the per version information improve a bit, because when I'm running a particular version of MariaDB, sometimes it's not as easy to figure out which features I have and don't have. So I think there's an area there where we could improve, and there's examples we can look at in other software where they have that same kind of thing. So I think we can look at others and learn from them as well. Code-based maturity. Hey, Code-based maturity is an area where MariaDB, I think, does very well. The version numbering makes sense. It's very clear to understand when something is a release candidate or when something is prime time. So that's really good. And also the change logs are always informative and are good to give me the update I need for what changed in this version. So overall, there's a bunch of areas that I would like us in the ecosystem to consider when I look at the MariaDB ecosystem and the MariaDB server code base especially, and I compare it to the draft standard that the Foundation for Public Code is publishing. I think there's some areas that this causes me to highlight as areas we could improve, and I've talked about them, especially around documentation, reviews relative to the various standards. Can we get some branch rigor? There's more we can do in terms of testing and roadmap. Let's get some engineering guidelines together. Maybe I can work on that. And obviously the internal modularity, I think that's the most difficult one. But with all of this, most of the time what I'm talking about is we can do it the way they do it over there in MariaDB. That's a community that is doing a lot of things really right. So thank you very much, and I understand we're going to have some question times now.
Thank you, Eric. That was a great presentation. I think also it was the most unconference-like unconference-like presentation in this conference. You were talking from a developer perspective and towards developer, which I think is great. And I have a couple of questions about that, but one housekeeping issue. First, remember everybody listening in here and watching this that the chat is going on in Zulip, and the Zulip possibility also means parallel processing. So people approach the previous speakers, Dupes and Victor, at the podium later on, and while Eric had already started his presentation, they gave the answers to those people who have approached them with questions on Zulip afterwards. So do look at Zulip also afterwards. We have topics for that. But now, Eric, so my key observation of your presentation is when I was comparing what you do with the Foundation for Public Code and what we do, including you, with the MariaDB Foundation, we have the two pillars of openness and adoption. Openness meaning taking code contributions and working with the developer community, where developer means those who develop the software itself rather than using it. You were mentioning that on the adoption side, well, that's sort of not your task. You're not persuading people that open source is a good thing. Well, that's sort of not what the foundation, MariaDB Foundation, is doing either, but we do persuade people that MariaDB is a good thing. So what do you do? I understand that the Foundation for Open Code doesn't say open source is great, but it probably has some task in saying that the software that you develop is great. Do you have that?
So I think, so when I work with a development group in say, for instance, I'm working with the Signalen group in the city of Amsterdam, and also with the collection of cities, the VNG, which is the association there. We might occasionally have a discussion about is there some data that can be made for the machine learning training model that can be made public so that it is easier to have another organization tweak and hack on the machine learning model, because without any data, it's not you can't really adjust the training of a model. So that's like an example of where the subject of how do we be open and how can we be open might come up. But I never have to have a conversation about should we in fact be writing free and open source software. These are well understood. The notion of exactly what can and can't be but out there is more data oriented.
I was thinking along the lines of, let's say that I think it's a good idea to have open source for municipalities. But how do I get to hear about VNG and about Signalen? How do I know that those particular ones even exist?
Right. So that's why one of the things the Foundation for Public Code does is it works with the code bases to make sure that they have really a product, not just a project, so that it has a website. That website has decent searchability, so that when you do your standard web search, that naturally in the search results you will find links to the components or to the code bases that you would use like this. So in that sense, working with the code bases, the people who are contributing to them, the civic organizations that are investing in them, making sure that the investment is not just in the code, but also from the adoption angle, like you say, that it has a decent website and that it has good documentation, that I can experiment with it if I am in another municipality somewhere else or another province or something like that. Does that answer your question?
Yeah, that does. And you were talking about civic organizations, so I was also from a slightly different angle contemplating the role of civic organizations and then commercial entities. And I'm talking about commercial entities that create software for the civic organizations. So I didn't hear you mention many of these, shall we say, commercial parties. What's your relationship to them?
Well, so I think that in many cases, if not most, but at least in many cases, development isn't really happening by people that are necessarily themselves developers and also civil servants. In some cases, it absolutely is, but very often that's contracted out. So it's being managed by a government organization, but very often the developer themselves is employed by a commercial firm that is providing development services to a civic organization so that the civic organization can develop the software that they need to deliver the services that are their requirement to deliver. So absolutely these vendors, and it's not only development vendors, it's also hosting vendors and other sorts of what we think of as support, that there needs to be a vendor support network around any code base, just as we see happens with around MariaDB Server or any of the connectors even, that in addition to there being some main developer parties, there's also smaller third parties out there that are providing DBA advice or tuning services, so professional services and support that are coming from a variety of commercial interests.
Cool. So within these entities, like the civic organizations, the commercial entities, you'll probably see developer type people who focus on code mostly, and those who are looking at shall we say, commercial aspects and usage and advocacy. Any comments, very brief ones, we have less than a minute left. Any brief comments on the type of personalities involved?
Yeah, sure. So I think I have probably as many bad stereotypes in my head as anybody else does. And what I've discovered is that developers who work on public code are an absolute joy to work with. They have a lot of overlap with the free and open source software developers that I encounter in other communities. And in other communities, I see very often one of the many motivations for working on FOSS is contributing to the growing body of public knowledge that is free and open source software. And in public code, what I see is a similar trend where all the developers feel like one of the important things is working on contributing to the betterment of the society. And so I think that's a very close parallel. Most of these developers could go make more money in commercial world, but instead they choose to work on this stuff because it's
excellent point, Eric. Sorry to interrupt you, but those were really good concluding remarks. I very much like your presentation, and everybody go to Zulip to ask more questions from Eric. So thank you very much, Eric.
Thank you.
Next up, a core developer of MariaDB Server, Sergey Petrunya. Analyze for statements, MariaDB's hidden gem.
Hello, my name is Sergey Petrunya. I am a MariaDB developer, and this is a talk titled Analyze for Statements, MariaDB's hidden gem. Analyze for Statements is a feature in MariaDB. It is actually not a new feature. It has been introduced as early as in MariaDB 10.1. And I think it got much less recognition than it deserves. That's why the talk is titled Hidden Gem. It was improved in the next MariaDB versions. We improved it based on experience we had with it while diagnosing real-world issues. And finally, in MySQL 8.0.18 last year, there was a feature introduced called Explain Analyze, which is very similar. So I thought it would be a good time to talk about Analyze for Statements again and also compare it with its MySQL counterpart. So the plan of the talk: first we'll look at Analyze in MariaDB. There are two variants of it, Analyze and Analyze from JSON. Then I'll describe Explain Analyze in MySQL, and we will compare the two features. Before we talk about Analyze, let's have some background. What do you do when you got an optimizer problem? The first thing to check is to look at the explain. Explain shows the query plan, and sometimes the problem is immediately apparent from the explains. Like, for example, explain may show you full table scan, and you know your query shouldn't be scanning all rows in the table. In other cases, the problem is not as apparent. One of the things that you don't really know whether query plan matches the reality. The plan has numbers of rows that the user expected to read, and numbers of fractions which would expect to pass the where condition. We don't know whether that matches the reality. And the second crucial thing it doesn't show where the query would be actually spending its time. Like here it is not clear which of the tables will take more time to read. Is it scanning all of this table, or is it making index lookups into line item table? Enter Analyze. If you compare it to Explain, Explain optimizes the query, and after the optimizer finishes, it prints the Explain output and finishes it. Analyze also optimizes the query. Then it actually runs the query. While running the query, it discards the query output, but it collects execution statistics. And then it produces output that's very similar to Explain, but annotated with the statistics collected during execution. Let's take a look how it looks like. Here we run Analyze, select, and then there is a join. We are looking for all orders made between these two dates, and then those that have items in these orders which have price greater than 1 million. We see that in Analyze output there are two extra columns, R rows and R filtered. R stands for real. That is, R rows is how many rows were actually enumerated in that table, and R filtered is what was the observed condition selectivity. If you look at rows, for full table scan or full index scan, these are typically close to the expectation. The expectation about how many rows in the table is precise, although they can be very different in case of limit or subqueries, where the optimizer will cut the query execution short. For range access or index merge, the other range-based access, it depends on the storage engine. Within the DB, you can expect up to 2x difference. You can have a bigger difference in edge cases, in which case basically the workaround is to ignore index. The most interesting rows is when the type is ref. It is ref is making index lookups based on the lookup value constructed from previous table. Like here, for each order, we make a lookup and we expect that there are two items in the order. What we have observed, actually, we saw that there are on average 4 items in the order. Since this is average, some amount of discrepancy is normal. But sometimes the discrepancy can get very large, tens, hundreds, or thousands, and then it's worth investigating. For example, an important special case is when rows equals 1, while real rows is much greater. That means you don't have index statistics and you should rerun analyze table. If you see there is a huge discrepancy, it's worth rerunning analyze table as well. Then if the column has lots of null values, by lots I mean more than half of the rows have nulls, it's worth looking at in the dbstats method. Otherwise, if the column has very skewed data distribution, like most orders have only a few items, but there are also some really huge orders, well, then the situation is complex. One advice would be that if an index cannot produce reliably good query plans for you, you should consider ignoring it. The second important column is rfiltered. Rfiltered is selectivity of using where, how it is a fraction of rows which will be left after using where here applied. And here we see that using that after table line item rfiltered is 0, that is no rows passed this condition. And if you see rfiltered is much smaller than 100, it means the query is reading and discarding lots of rows. The first rule to do is that check if conditions in the where clause are in the form that allows index use. You can use explain or analyze format JSON to see what the condition is attached here. Look at consider indexes. We could here add an index on extended price if this is if you are very frequent to have queries querying on price. However, one should not change filter at 100%. Because there is always a trade-off between reads and writes. Adding extra indexes has extra cost. They slow down updates, they make your database larger, and make the optimizer job more complex. One other angle that you need to know about rfiltered is that since filtered it shows how many rows will be removed from consideration, it is very important value for end-way join optimization because it shows how many rows, how many times the second table will be accessed. So if you see rfiltered and filtered being very far apart, typically it will be rfiltered much smaller than filtered. This shows that the optimizer has a wrong idea about condition selectivity and it might be producing poor query plans. And if you can't afford adding an index, consider at least collecting a histogram so that optimizer knows that in this case that condition on L extended price is going to be very selective. Summary for analyze. There are 2 new columns, real rows and real filtered, which allows you to check the estimates with reality. Now let's move to analyze format JSON. Analyze format JSON is explain format JSON meets analyze. The syntax is analyze format JSON, and if you look at the basic query, like here we see it produces JSON output. It's similar to explain format JSON output, but it also has extra members, quite a few. In blue you see there are real rows and rfiltered, which we are already familiar with. And there are also more marked with yellow. rloops is number of times the operation was executed. Here the query was executed once and the table was scanned once, so rloops is 1. Then there is R time ms. R total time ms is total number of time the query took, so 190 milliseconds, of which 142 milliseconds were spent reading from the table orders, and 48 other milliseconds were spent called other time, that's checking the where together with other auxiliary info. There is no further breakdown because taking time measurements too frequently has an overhead. So there is a limit about how often we can note the time. Let's try a more complex query. Let's get back to the join we had a few slides ago. Again, line item and orders. Here we see that there is a query block. It's got R loops and R total time ms, 4 seconds in total this query took. Then if you look at table orders, it was read one time. It took 300 milliseconds. So it was a full table scan, but it wasn't the worst thing about this query. And if you look about line item, we see that only 4 rows were read each time, but it was done. The table was accessed 1.5 million times. So in total, reading from the table took 3.5 seconds. And this is the lion's share of the query time. Checking the where and other auxiliary took 150 milliseconds, so it's probably not okay. Now one could say that you could guess that from this query, but for complex query with selective where condition, its R loops is really useful, and R total time ms allows you to instantly see where the time was spent. Let's try it with the subquery also. Here is the subquery. We find orders on these dates such that the sum of this order is 90% of what the user has ordered in total. So user's biggest order. Each subquery has an R query block entry which has R total time ms. So here we see that the mine select took about 1 second, and the subquery took also. So the time was split between these two nearly equally. Again, when you get a large query with lots of subqueries, it's really helpful because there are subqueries which don't look as heavy like this one. It reads just seven rows, but it is executed multiple times, so it adds up. On the other hand, there can be subquery which takes some time, but it only executes a few times. By the way, here we can also see that the expression cache was used for the subquery. It got about 200 hits, had a hit ratio 0, after which it has disabled itself because it was not helpful for this query. Let's look at some other operations, for example, sorting. Explain in MySQL and MariaDB shows using file sort, which may sound too scary for some people because they think that we're going to actually read files. The second frequently asked question is, what sort buffer size should I have? Is my setting large enough? The third question, those who read there is a priority queue optimization in recent MariaDB and MySQL versions, and it is not shown and explained, so you cannot really easily see whether it was used. You can see it from the counters, but counters don't show it really does multiple sorts, whether some of them are doing it or not. So here we can see that for query with limit, we find 50 customers of greatest balance. We see that the query used priority queue, so it wasn't reading or writing any files. If we search for the top 50,000 customer, the picture is different. Priority queue was not used, but we managed to do one sort pass. Buffer size was 2 meg, and the data fit apparently into one pass. That's very useful. Analyze works for any statement that explain works for, so you can run analyze update and analyze delete. You should, however, be cautious because analyze update will actually do the update and analyze delete will actually do the delete. Here we follow PostgreSQL explain analyze feature, and I think that is the right way to do it, because analyze should be as close to real query execution as possible. If you don't want analyze to make modifications, you can wrap it in begin rollback, wrap it in a transaction, and that way, this is a way to avoid making the changes. One important question is the overhead of analyze. Analyze data there are two kinds. First of them is counters, how many rows were read. These are cheap to collect, and actually MariaDB will always count them. And then there are time measurements. Time measurements are expensive to make, especially when you need to have many of them. When we're reading rows for table, we basically measure the time each row read took. But maximum overhead that I was able to observe was 10%, and that was on an artificial example that I have constructed specifically to maximize the overhead with very small rows, very small tables, but doing many reads. Typically, the overhead will be less than 10%. Analyze and the slow query lock. I guess experienced DBAs here know that MariaDB and MySQL have a slow query lock, which writes slow queries. And you can also say in MariaDB log slow verbosity explain, which would we should say it's writing explain output into the slow query log, but actually it's writing analyze output. You can see R rows and R filtered. So this way, if the query is slow, you will get its analyze in the slow query log. One would say that analyze format JSON would be nicer. Yes, it would be. There are two obstacles towards printing it. First, that there is no timing data, because as I said on the previous slide, analyze format JSON, so analyze has some runtime overhead. We didn't want it to be always on. So by the time we decide that the query was slow and should go into the slow query log, we already have run it and we haven't collected the timing. Another obstacle is that most common use for slow query log is to run it with parse it with PT query digest, and I'm not sure how to print JSON here in a form that's usable but without interfering with ability of PT query digest to parse it. So, summary for analyze format JSON. It is explain format JSON execution data, are rows, are filtered, are total time MS, and are loops are members that are useful to narrow down problems. Sorting, buffering, subquery caches also report error values about their execution. Please do attach analyze format JSON output when asking for optimizer help or reporting the issue. Will save one round trip. Now let's look at MySQL 8. MySQL 8 got explain analyze feature in MySQL 8.0.18, which was in October 2019. They had fixes and bugs in it and fixed it in subsequent releases. But now I think it's stabilized. It produces a PostgreSQL-like output. It's shown below, so it's a tree-like structure. In the next slides, I will be editing it for greater readability. The reason it produces PostgreSQL-like output is that it has switched to so-called iterator interface runtime under the hood, and after you do that, one can implement, explain, analyze in Postgres-like way very easily. So the basics, let's run explain analyze for one query. We see that it shows query plan basically with costs and expected number of rows, and it shows this actual time rows and loops. Loops is like MariaDB are loops, how many times operation was done. Rows is the number of rows in the output. So if you want R filtered, you get the rows produced by the range scan here and divided by the rows that would left after filtering. And that you compute R filtered. Actual time shows two values. The first is the time to get the first tuple, and the second is time to get all output. They're not total time MS because if the node was executed multiple times, these will be averages. But R total time MS is basically this multiplied by this. Let's look at the more complex query. Here you can see the MySQL's output on the left and MariaDB's output on the right. You can compute our total time MS by taking the second value from actual time and multiplying it by loops. So the usage will require some arithmetic practice, but you can get the same value, yes. For sorting, they show the limit. Here I run again two queries which we ran previously with MariaDB. We show that there is different limit, but it doesn't show whether the priority queue was used or what was the buffer size. It's interesting that specifically for sorting, you can get this information from the optimizer trace. If I run the query with limit 50 and optimizer trace on, I see that file sort priority queue optimization is chosen. And with 50k, I see that it's not chosen and there is a peak memory used. Update delete. If one attempts to run update delete, you will get this error. Apparently, single table update and delete statement are not using the iterator interface yet in MySQL. So explain analyze doesn't work for them. Multi-table update works, and unlike in MariaDB or PostgreSQL, it won't make any changes. So summary, the syntax is explain analyze, Postgres-like output. Unfortunately, not all plant details are shown. Some are in the optimizer trace for some reason. Not all kinds of statements are supported. It can have higher overhead. If I retry artificially bad example, I get about 50% overhead. As far as my guess about why it happens is that they are doing many more timings, taking more timings, and that has more overhead. They show some info that MariaDB does not show. They show time to get the first row, which you don't have in MariaDB. They show number of rows output for each node, and they have nodes for grouping operations. I think nodes for grouping operations would be nice to have for MariaDB. Number of rows output for each node, we need to check this out. Time to get the first row, it might be useful for cursors or other special cases. I'm not convinced that it's worth printing all the time. Let's make a final conclusion. MariaDB has analyze statement, analyze from a JSON. It is a stable feature, very useful in diagnostic optimizer issues. MySQL now has got explain analyze. It's a similar feature, but it has a different interface. Data is different and printed in a different format. There are some things it has that MariaDB doesn't have, but so far I don't see any obvious advantages. If you think otherwise, feel free to file issues or feature requests and we will fix it in the next version. Thanks for your attention.
Thank you, Sergei Petrunya, for a great analysis of analyze. Very good. I always thought that a full table scan was your worst case scenario, but you clearly explained why that is not the case, that there can be worse things than a full table scan. But one of the questions I was pondering here is, analyze output, yep, fine, but what's then performance schema? Shouldn't you get those answers from the performance schema?
Well, performance schema was initially designed to get overall aggregates about total system health or total system behavior, how much I/O on the whole you have on the whole instance, while analyze is targeted at looking within the bounds of this particular query. At the moment, there is no overlap between these two features. They are separate. Maybe at some point we could see that the stuff collected and analyzed, like composite totals, get into the performance schema, which we to some extent do now. So that's like for the future, we should look at the integration of these two features. At the moment, there isn't much. Performance schema is more about composite
Makes sense to me. So I have a question from a different angle. So many of these things you read in a character-based format best to understand it. But are there any ideas for a GUI, a graphical viewer for this? Does it make sense? And is there such a GUI viewer?
There is no GUI viewer currently. I think it would make sense also. Well, SQL Server, if you look, it has a similar kind of feature which has a GUI viewer, and I think it would be useful here as well. I don't think anybody has any specific plan, and it would make a really nice third-party contribution. Or I would think there could be a website where you could paste your analyze output and get a nice GUI at the on the right. If you paste it on the left, something like that. So it's a low-hanging fruit for somebody with good front-end knowledge to take.
Low-hanging fruit. So there's a good trigger for somebody who wishes to contribute. So now on the borderline between performance schema and analyze, you said a performance schema is for the overall situation and analyze for the individual query. But what about the RAM that the query used? Is that something for analyze to show or performance schema? How do I know how much RAM memory was used by the query?
Analyze, I don't think, maybe it's not 100% finished work, but analyze already shows the amount of memory used by file sort. I don't think it shows the amount of memory used by temporary tables, but this is an obvious low-hanging fruit. I think we have a total counter about how much the statement has allocated. So this is a good example where analyze would show which individual parts used the memory, individual parts of the query plan, like grouping operation or window function operation or something. While performance schema would show the totals, how much the statement used together. Maybe the totals could be had in both places, like in the same like query time. Analyze has R total time MS, and performance schema has also query totals. So you can look at, so they are added into the totals summary view. Yeah.
Right. So then I had an idea here related to somehow optimizing the optimizer. Can you somehow feed the analysis that you got from the analyzer to the query optimizer, and then the query plan will be better?
Yes. Well, one tricky thing here that analyze will show you what it has seen, but it will not show you what it has not seen. So if you see, it will allow you to tell you that, okay, this condition is actually highly selective, or that this index was bad. It won't tell you that other index was better. But yeah, I think the idea is very good. Unfortunately, we cannot have anything at the moment. We might need some. We could have it to introduce some sort of selectivity function. Okay, this is a kind which you will wrap a condition saying, okay, this is a condition, and I know its selectivity is gonna be this. This is one of the future directions. I don't think we have any specifics yet, but it's on the list of what we are like thinking of.
Cool. And I see you've been active, both the participants and you replying on Zulip chats. Anything you, Sergey, wish to fill us in from the Zulip chat that you had on this topic?
Let me check. Well, it's just some details. It's mostly all answered in Zulip. Eric has shared an interesting observation that ignore index works better than force index. This is like a revelation to me, because apparently Eric has done quite a lot of work running production databases. For me, it was they were identical, but it's an interesting observation for me. Yeah, Marco has asked about whether table time MS includes pushed filter. Yes, it does. It also pushed index condition. It just computes the time we spent waiting for table to read to complete. Yeah, and
Hey, that's great. So I'm very happy to see that you got revelations from Zulip. Our plan was for the participants to get revelations from you, but if it's mutually revealing, then what could be better? So thanks for a great presentation on Analyze, Sergei Petrunia. Thank you.
Thank you, Tom.
Now for Sanya Alexander Bielkin. How to get your bug fixed fast.
Hello, my name is Alexander Bielkin, also known as Sanya. I am working in MariaDB Corporation as a developer. Today I want to tell you how to make your bug fixed faster. So, what can you do about your bugs? Of course, you can do nothing. Eventually, it will be fixed, but it takes a lot of time probably, especially if it's code not so many people are using. So, what is better? Better you have to invest something. For example, simplest way probably for somebody is money. You pay for support. Support help you to prepare a test case for the bug. Also, support bugs are have higher priority. But there are other ways. You prepare excellent test case and bug report, and then developer do not spend a lot of time on trying to figure out what to do and just start fixing it because problem is visible. Also, consciously or subconsciously, developers prefer some well-defined bugs with clear test case. Or you can do even both to make good test case and to pay for support and so get some high priority. But what developers want from you? Developers want the only thing, how to reproduce the bug. Another word, test case. So what could help reproduce the bug? The query which caused the problem. It could be just query script, which has several queries or some step-by-step instruction which query to execute. Also database, like database dump or with all these tables, functions, and other structures related to the query. Also, it will be better if you, in clear words, describe what you wanted and what you got. So what's the problem? Also, it could be stack trace if it crashed. For some bugs, probably for most bugs, server version also important. We have not so many server versions, but you probably know what server you run. If it's really difficult to find exact version, just major number is enough, like 10.5 or 10.1 or whatever. Server configuration. Sometimes if you have some not usual server configuration, it's important. Or even if you have usual, but sometimes it depends on server configuration. But okay, if it's really difficult to get all configuration, maybe it's not, you can spend time on. Operating system, there are bugs which depend on operating system. Not so many. Environment variables, so it's really rare that they help. So, the query. Where to get the query? Of course, it could be that you just know the query because you are writing your application, or maybe you just issue queries, handmade queries to the server. And it's rare case, but easiest. If no, then you probably could check your logs. Or first of all, you have to switch logging on. So general query log has impact on performance. So just don't do it like for all the time and just in hope to get something. So switch it on temporarily. It will be even better if it's not production database and you can just repeat the problem on your toy database. Also, you have to know that if there are many connections to the server, your query, like query which caused the problem, could be not the last query. It will be the last query in that connection which caused the problem. But there will be a lot of other queries around. So if you gave us your query log, it's better to get several lines, not the last, and maybe all if it's not security important. Also, if server crashes, crash report procedure, try to write query to the error log. Sometimes it's impossible, sometimes it's do not get the query, but still maybe you have query in the error log. It's worth to check. How to solve what problem actually have sending us database? Database could contain confidential data or some private data, and also pay attention that whatever you attach to bug report in our Jira, it will be public. So if it's not information you want to see to everybody, you better upload it on Foundation FTP. There is an article in MariaDB knowledge base how to do so. And the other problem with database is size. There are some really huge databases, and it's not comfortable to send all of them. Okay, so of course we are happy to accept any size of database and any contents. We promise do not use it except just reproducing the problem, but still better be safe than sorry. So how to solve this problem? The easiest, simplest way, but not the most useful variant, is just to give us schema only schema or without data. So it's definition of tables, definition of procedures, definition of triggers and other stuff, but no data. Even in this case, it's better say something about data distribution, just because you probably know how data distributed. If you have more time, you could spend time on filling the database with some random or generated data and reproduce problem on the database. If you do not want us to see real table names or real field names or procedures names, after reproducing, you can just in, for example, in text dump of the database, change it on T1, T2 or something like this. But it's better after this check that problem is reproducible on this database. So what mistakes I saw? Of course, it's maybe some biggest mistake was filtered before I saw them. But still, many people trying to prove that there are some bugs. We really believe that there are some bugs. But it's not what important to us. It's important how to reproduce the bug. So don't spend a lot of time proving that there is some bug there. Just spend a bit more time on finding the way to reproduce it. Also, sometimes we get like very detailed description of operating system, of all setup of the server. But if it's usual standard configuration, usually it's not what we want. We want something reproducible. Sometimes we got only stack trace and nothing more. Okay, there are some bugs which could be solved by stack trace, but it's very, very unlikely. So even if you have only stack trace, it's also better to allow core dump and send us core dump with your binaries. Or maybe even with some libraries if it's needed. Because core dump can be viewed with debugger, and sometimes we could find something there. But to have good stack trace, core dump, one should install additional packages in the system. Packages with debugging symbols, because otherwise even stack trace will be useless completely. So it's about this. So now let's try to make a bug report. To make a bug report, you have to be registered on Jira MariaDB org. So here in the top there is create button. Right? You got form to fill. So first of all, projects. It's important to correctly say what project has a bug. So let it be server. Then issue type, it's bug. Okay. Summary. Just put summary like you think it is. So let it be some function produce wrong result. Priority. Priority, it's okay, leave it as is. But if you feel that it's very important to you, you of course could put it like critical or even blocker. The problem is that this the same field also used for our internal priorities. So after this, when bug will go in procession, like we will just do something, we will set there our own priorities. But still you can state how important it is for you here. Components. Components, it's something really difficult to define sometimes, even for developer, until its bug nature will be found and fixed. So just leave it as it is. If you're not sure, it's okay. Affected version. Here, if you know, you can just put version, like, for example, full version. Or if you're, okay, no, only general version, you can just do it also, for example, like this. Environment. As I told, don't spend a lot of time here, but okay, you can just put here Linux, for example, or Ubuntu. It's okay. Description. Here it's better put some description and better formatted nice. So let's write it. So, As you can see, I put here some formatting things. Of course, query itself better cut and paste than write it just to have no mistakes, types, typo in it or something else. Also, so what else? Okay, here I wrote that it's attached database. You can just attach here as a file or just put it on FTP. Then you have to write here that you put it on FTP, file name and other stuff. So let's create it. It will take some time. So here is our issue. And also it was spend some time, read the bug just to check that there are no mistakes or errors in it. So just look through what we have here. Some function on the uploaded away. If you need, you can just click and you got form to edit. Then, okay, also with other fields, as well as it could be edit like the same form that you saw before, or almost the same. So it's okay, your bug created. So what then? Then, as soon as you have some changes here in the bug reported, you will get email. What to have pay attention to? Comments. Here you can just add your comments, by the way. Also, some other people will put here comments. It could be communication between developers and support, or between developers. Also, it could be internal notes of developers, but also it could be question to you. Maybe something to define or something else. So just pay attention to comments, check if it's something asked. Also, there is a label field. Here could be label need feedback. It's clearly shows that developer or support or whatever who now processes the bug needs some information from you. So it will be better to answer. So that's what you have to know about bug creation, and then answering question and other stuff. So here I put in the presentation all this just as notes, just because probably the presentation will be available on the web. So here's description of the fields I already presented to you. There are many other fields there, but they are mostly used for technical things by developers or support or other people. So it's about communication. And what if you still have time and inspiration to improve your bug reports? The clear way to improve the bug report is just reduce test case. But remember, before any improvement, just save what you already have, just to do not just lose it. So, what you can reduce? You can reduce database. Just remove tables which are not used by the query. You can just remove fields maybe from the table which are not used, or indexes. How to check if index is used? You can just check explain, for example. But in any case, if you remove something, check again if bug reproducible. So if no, just revert your changes. Also, you can simplify your query, because we could have like really big queries. So what you can, so especially if you have some suspicious part of the query, which is unusual or only in this query, or by some other reasons you think that this part cause problems. So just try to remove tables, maybe remove some clauses like while or from, or not from is impossible, like having or row by or whatever. So maybe they're not needed, or some queries, some functions maybe are also not needed here just to reproduce the problem. So this is not mandatory or just, but just can help later, because in any case this work will be done by somebody before bug fixing or during bug fixing. So that's all. I hope after that you will report really nice, tight bug reports. Thank you.
Thank you, Sanja. Thank you, Alexander Bielkin. Really good presentation and really good to see what it looks like from the other side. I'm thinking of myself as somebody who suffers from bugs, not necessarily in MariaDB Server, but otherwise. I'm thinking about these jokes. How many MariaDB developers does it get to fix a bug? Or how many bug reports does it take to convince these developers that there actually is a bug? But I suppose that the gist of your presentation is that those are wrong questions. From your standpoint, I think the undercurrent was, please make the bug reproducible. But why is it so important from your perspective to make the instructions for how to reproduce?
It's first of all, because to fix bug, you have to somehow localize the bug. And actually the bug and its what you see, it could be different. For example, if it's crash, you think that actually crash reports, the stack trace is where actually bug happened. But in many cases, it's just consequences of bug happened somewhere earlier. So to localize the problem, we have to repeat it in some artificial conditions like under debugger and with many debugging logs. So otherwise it's looking for a bug, it's like looking for a needle in the whole stack. So it's very, very, very important, very difficult. So if you don't know where to look, you couldn't fix it. It's one aspect. The other is that after fixing the bug, first of all, we want to be sure that we fix it exactly that bug you reported. So we have to repeat it and see that it's not happened. Even more important, we don't want this bug to be appeared again. So actually all these test cases end up in our test suite, this regression test suite. So each time we do some changes in the server, it will be checked again. And we are sure that it's not happened again. That's why we need this, the way how to reproduce it, a test case.
I think that makes a lot of sense. So yes, you do need how to reproduce, but what if it's hard for me to reproduce? Is it sort of, it's on my duty as a person suffering from a bug to explain it in such a form that somebody else can take over?
Yes, if you could not reproduce it, it's better to give as many information as you can, or at least answer questions. If you can just give more, or give something you haven't thought in the first place. And okay, there are some bugs when without test case we can kind of guess what happened, or even by the stack trace and other things, but not so frequently. But Yes, of course. The more the better. Ideal is reproducible test case, but if you do not have, so we understand that it's sometimes really, really difficult. So give us what you have, but the more you give, the better and faster it will go.
So I think that's your top request from anybody suffering from a bug, that as much information as possible should be given towards the reproduction of the bug. But it seems that you also listed a bit of, shall we say, spam information that you're not all that happy about, that it's just distracting you.
It's not like distracting us. It's just people spending a lot of time on this probably, and like proud of themselves, think that they give a lot of information, but in fact is information which is not really helpful or sometimes difficult to use. So there are, if you have some amount of time and everybody kind of limited in time, it's like I just tried to show where is better way to spend your time than just listing a lot of things which probably not useful.
It happened on a Tuesday, and it was after full moon. It's probably not the most relevant information. Okay, so any other wishes then? Like, if your top request is, please say everything you can to simplify my life in making the bug reproducible. Is there anything else, like how to report it on Jira? What's your second most important request?
Second most important request is keep an eye on the bug, like on this email you gave. And if there are some questions or some details you can say, just put it there. And even if you forget something, like, and then recall, oh, I probably want to mention this, just go fix the bug or just put comment in the bug. So it's sad, but we could not fix it like instantly. So the bug will live with their life, and it's better to keep an eye on this life of the bug.
And the life of the bug is portrayed on Jira, right?
Yes, it's the Jira is most the source, the main source, and of course there are these emails which will be sent for people who just watching the bug, and there is also a channel in Zulip where something happens, but it's all together goes there. So it's many ways to keep an eye on the bug, but okay, the source of all changes you can see in Jira. And even if you do not understand what the mail come to you, just go on Jira and see the bug report, probably more clear, because emails sometimes are a bit vague, just difficult to understand.
Right, so Jira is the place, that's one of your other key messages. Jira is the place to get the overview of the bug. As a user, what is it okay for me to put on Jira? I mean, of course, I won't put any information that is business related on the how to reconstruct, but I mean, is there any guidelines on what I should provide and what I should not provide over Jira?
Okay, so of course, it's better do not provide any confidential information, because all you put on Jira is like worldwide visible. And if you have such information, as I told, just say us, or you can just say in the comment, it will be open, but okay. And then that you put it on somewhere on the private FTP of Foundation FTP, or maybe we could communicate other ways to pass this information. All other, okay, it's okay, put everything you want, but not please don't put there something private or something about products or whatever.
I hear you. So those were very good comments. So you wish for a how to reproduce that is as good as possible, and if I can't reproduce it completely, then as much as possible. So that was a great presentation. Thank you, Sanja.
Thank you also for hearing and probably for good bug.
Our next presenter, Valery Kravchuk, MariaDB 10.5 new features for troubleshooting.
Hi, my name is Valery Kravchuk. I work for MariaDB Corporation as a principal support engineer, and today I'm going to present you a few details about new MariaDB 10.5 features related to troubleshooting. I'm presenting this from a small town of Vyshgorod, near the capital of Ukraine, Kyiv. I work in MariaDB and MySQL support for more than 15 years already. And in recent years, I'm also a community person, a public person with a blog, a lot of MySQL and MariaDB details published on my Facebook page, with a Twitter account devoted mostly to MySQL bugs. Before that, I was a trainer and consultant working mostly with Oracle databases, so it gives me some Oracle background that is related to today's talk, and I've worked out a habit of creating a simple and clear presentations that can be also used as a reference. So whenever you see an underlined item in my presentation, you can click on it and get a lot of useful and way more interesting information than in presentation itself. I think so. So it's a reference. I should say that I work as an independent consultant. I'm not a marketing person for MariaDB Corporation, so all the views and ideas in my presentations and writings in public are my own, and I do not speak for MariaDB Corporation in any way. This session is devoted to the new 10.5 features in three main areas. First of all, finally, we got more or less incorporated all the instruments and ideas from MySQL 5.7 performance schema. So performance schema became way more useful. Then we also added some tables to the information schema to make the internal workings of the yet another killer MariaDB feature, namely thread pool, more visible to the end users and DBAs. And there was also a small improvement in the analyze statement that allows to present the way query was executed with details about rows and time spent. So a bit more details are included now. Most important is surely the performance schema improvements that all our users are waiting for several major releases already. To understand how large was this change, we can compare the number of tables in performance schema. That was 52 in the previous release, comparing to 87 in MySQL 5.7 and 80 in MariaDB 10.5. Few tables are still missing, and these tables are mostly related to the group replication feature that we do not have in MariaDB. If we speak about the related variables, we are now having the same number, 42 variables that allows us to set something related to performance schema. If you ever read the new features of MariaDB 10.5 knowledge base page, you will probably noted a section what's new in performance schema that refers to the tasks that were implemented by dev numbers. You can surely click on each and every of these numbers to see what was implemented, but the details there in public tasks are quite limited, so it's not really that much useful. So we will just use it as a reference of what additional details are now instrumented. So we have additional memory instrumentation, metadata logs instrumentation, prepared statement instrumentation. We instrumented status variables at global and server levels, added some instrumentation for storage procedures, added some instruments for SX shared exclusive logs, locking primitive widely used in InnoDB, some instrumentations for transactions, and the last but not the least, for me specifically, is the way to get the values of user variables in user sessions. Previously, one had to apply tricks like reading the internal structures with GDB that I personally had to do. So I really appreciate this addition. A couple of things are not clearly documented, and of them we have several replication-related tables in the performance schema. It's work in progress. It's not yet completed for 10.5. And one important thing for all of you to note is, unlike previously in 10.5 and in MySQL 5.7 and newer versions, we have one important change in the way performance schema works. Previously, it had allocated the memory at startup. So whenever memory grows at runtime, you could be sure that performance schema is not a part of this leak or supposed leak, whatever is it. It's no longer the case. In MariaDB 10.5, some memory to the performance schema instruments is allocated dynamically depending on the load, number of connections, number of tables opened, and things like that. So it's important detail that I wanted to highlight. This highlight actually goes to one of my blog posts where I studied this and presented. So to summarize, instruments, performance schema still controlled in the same way as before. If you want to instrument something, you have to enable specific instruments, and you do that through the performance schema setup instruments table. So we have additionally, just for memory instrumentation, added 270 instruments starting with memory. That's cool. They cannot be timed, but they should be enabled. Some are enabled, some are not enabled. Important thing about the instruments is, and it's presented in my blog post, that some of these instruments are not enabled at startup. And even though they are dynamic, unfortunately, some of them can be enabled only at startup. Think about the MariaDB thread pool. So the huge memory allocation for a thread pool. So to see it in the performance schema tables, you have to add in your CNF file the appropriate enablement. So all that you can see, it's just a small detail. It's common for MySQL and MariaDB as well. So besides instrument, these additional memory allocations are represented in 5 additional tables that were added. You can see the structure in the MariaDB knowledge base, and we will study one of the tables. Memory summary global by event name. So for each event representing specific place where the memory is allocated, there are a lot of details presented. Additionally, in other 4 tables, we have this split or detailed for example, for a specific user and host in memory summary by account by event name. So account is represented by a pair of user host as it's normal in MySQL and MariaDB. You have a summary by host, so different users from the same client host may be checked for the memory usage. And you have a summary table per thread. So you can find out which thread, which user thread uses most of the memory or allocated a lot of memory in specific area. To find out the real MySQL connection ID that you are interested in, you have to join this to performance schema threads table, and you have to join with thread ID column, and there you can find out process ID for the related thread. So that's all interesting. These are additional fields. Let's check on the main fields. Main fields for each memory event are event name, surely, number of allocations, number of allocations, number of attempts to free the allocated memory of this kind, total number of bytes allocated, total number of bytes freed, and current number of bytes used. So the first 2 is related to the later of those highlighted. So total allocated minus bytes free is current number of bytes used. You have also high and low allocations historically, so you can see what was the largest allocation for this specific event. I also suggest you, really suggest you to check MySQL 5.7 manual, which is very detailed and have a lot of examples of this stuff. We can easily check memory allocations. It's a typical query, for example, find out which memory event, which kind of memory was allocated most often, for example. So top with limit 1, we have a top memory allocator. Where I've got this information from? Actually, it's a test that we should probably check. So I've set up for several examples in this talk. I've set up a simple sysbench test. It's LTP read-only that does some point selects, range selects, and whatever. So when it runs, it generates some load. And then in another terminal, I can check the result of this load. So if I look for memory, I can see, just sorry about that, I should add performance schema here. And we can see that top allocation, that's what was in my presentation, was actually for quick range select, so somewhere in the optimizer. You can see that current number of bytes used is really small, but total number of allocations was quite high because we have a high concurrency. Another next one in top allocations is some memory pool inside InnoDB. And I would like to highlight these interesting numbers here. You are not supposed to see negative numbers here, but you do. It's a known and open bugs in MySQL as well. So along with the feature that we ported, we inherited some bugs. Don't be surprised. If you're interested in the chat, I will show you these bug numbers so you can monitor them for further solutions. To summarize, the internals of the memory instrumentation are different. There is a discussion here in my blog with a key developer, Vladislav Weintraub of MariaDB Corporation, who explained what is the internal difference. Supposedly, our instrumentation of memory is more efficient. I highlight once again the important detail that memory now may be allocated dynamically. So performance schema is a source of kind of memory leaks. And surely we can see a lot of other details. I've demonstrated a bit different queries, so feel free to check different queries. Follow my blog post, I explain all this stuff there. Let's move on. Another additional instrumentation is devoted to metadata logs. We have a metadata log info plugin historically in MariaDB for quite some time. But in some cases, it's useful to be able to see the metadata logs info in the way performance schema presents. It's easier, it's always there, and it's easier to join if it's all in the same performance schema if possible. So there is only one table, metadata logs, single instrument like metadata, nothing fancy. You will see metadata logs for sure whenever anything runs. So just by selecting from the metadata logs. What about now? Now we have a lot of metadata logs, and surely it's tables from sysbench test. So sorry about that. It's all written on the slide, but I'm too lazy to just copy paste. So important thing here is also that if you want to find out which user connection had set the metadata log, you have to join to performance schema threads thread ID table and check process list ID there. So I will not go into the details of what kinds of metadata logs exist. It's nothing new was really added in 10.5 in this regard. Now, speaking about the performance schema, yet another area that we lack before for the visibility is prepared statements. Sysbench uses prepared statements. So now we can actually enable instrumentation, there are several instruments for both server-side prepared statements, like prepare and execute, and for API prepared statements, so-called binary protocol prepared statements, which are MySQL STMT, some C functions in C or other connectors. So there is a single table for prepared statements. So if we check it, we can select count. Surely you will see only active prepared statements there. So now you see 0 once again. That's because the test had completed. As soon as it starts back, we can see that Sysbench does use prepared statements for its activity. So here for this session, I enabled and set allowed to measure time for all kinds of prepared statements. There is one addition in MariaDB related to the feature that just does not exist in MySQL. It's execute immediate. So when you prepare statement in place from the string in one step and execute it. So that's additional instrument comparing to MySQL. So we see it works really. We can see what's there indeed if we just do this limit one while the test works. We can see there is some prepared statement. It's not even commit as in my case that I captured for the slides, but it's a real select of a kind that Sysbench often uses. So it's cool. Now status variables. It's the same that you can see with show global status, but when they are presented in the relational table, you can apply all power of SQL at the server side, not in your applications. Several tables were added, 8 in total. 3 of them are more or less unique to MariaDB. So we have just performance schema global status with current global status. We have performance schema session status for current requesting session. But what's more interesting, we also have access to status variables for specific thread. It's not unique, surely, but also for the account, for the user, and for the host. So we can like summarize how many read operations all users from specific hosts had executed. It's really cool. Yet another thing is storage procedures instrumentation. I suggest you to read and follow this work log from MySQL, the most detailed description. I cannot find anything similar in MariaDB knowledge base. So if you are not up to reading the code and all the tests and everything for specifications, just read the work log to get the general idea. So previously, there was only kind of object type that was instrumented. It's a table. View surely is also considered a table. With this change in 10.5, we added 4 more things instrumented, specifically functions, procedures, triggers, and events. Storage procedures. All of them are by default, you have to do nothing, are enabled and timed in all databases but system databases, MySQL, information schema, and performance schema itself. So you have to do nothing, you can just check everything. The statement to check is a bit non-obvious for somebody. For the events, you have to check statement scheduler instrument. All the other instruments, and there are many, are called statement SP, storage procedure. And you will not find your familiar commands, typical storage procedure commands inside. They're kind of abbreviated. So there are jumps, return, set, and everything, but not literal statements that you may be used to. Still, you can set all this instrumented, and then you can see how it works. Additionally, it's all timed, it's all included in all the summary tables. There is one additional table created, event statement summary by program. So for specific storage program call, we summarize all the times and number of calls for the specific events. As for a quick demo, I have here, that's why I had test, a small procedure called P1, very creative as usual. Sorry, I missed D. So that's it. It's a typical MariaDB storage procedure. It was created in Oracle mode, and you can see that we use, for example, implicit cursor and cursor for loop. It's cool stuff. So the procedure does nothing fancy really. You can just call it without arguments. It selects usernames from MySQL user table. But what's more important, that you can check the table now, event statement summary by program. So you can see, sorry, we have better to switch to performance schema. Yes, statement summary by program. So if we can check this, we can see that, for example, the procedure P1 was called 3 times, and here how much time in picoseconds was spent executing statements inside. It's nothing special. Call was instrumented previously, but now you can split it into the individual statements and get all the details. This is really a cool part that's yet to be presented in details. Another thing, so-called shared exclusive logs. These logs are used by the InnoDB implementation a lot, and we now have them instrumented. It's internal serialization primitive. It's interesting to check the instruments with name like SX log actually. Set up instruments where name like %. You will see some famous stuff here. So these are logs, internal InnoDB logs that every DBA and many developers should know, like dict operation log for dictionary, dict table stats for InnoDB persistent statistics, transaction purge ledge, BTR search ledge. All that stuff is quite important, and you often see it. Now it can be instrumented in detail, so you can see how much time in summary was spent on this stuff. So as for transactions, it's quite simple. There are 3 tables summarizing transactions. Current history, history long, related consumers should be explicitly enabled as well. What's more interesting is that now in MariaDB 10.5 we have 4 levels of hierarchy of events. So we have transactions consisting of statements. Statements are executed in stages, and each stage may have to wait for several events or specific waits. I will not show the demo now because I'm a bit out of time. I hope to present a link to the blog post while this session is going live in comments. The last but not the least is user variables. So there is a single table, user variables by thread, and you can see which user variables are defined in each thread and what is the value. It's easy. Let's just define a user variable and then select from user by thread. That's it. We have a that's from some of my previous tests. We have a variable named a with the value 1. Now go find out this without GDB from any previous version of MariaDB. It's really impossible. So that's the example. It's quite simple. Now, speaking about the replication instrumentation. Replication was also additionally instrumented. Related tables are just 4 out of 8, as far as I remember, in MySQL. They are only partially documented in the knowledge base. There is still work in progress because one of the important tables is missing. We have replication applier configuration, applier status, but we do not have a coordinator status. And if we speak about parallel replication, we have a replication coordinator thread and replication applier threads, maybe more than one. So all this should be documented and implemented one day. Probably it will be in 10.6. So speaking about the thread pool, for thread pool, we have 3 tables added. As far as I remember, in the information schema. So here we have to go information schema. And here desk, sorry about that, thread pool. Okay, I made a typo again. So that's it. We have thread pool QEs, we have thread pool groups. Moreover, I had not personally used it in real life yet, so I'm a bit slow trying to understand and explain at the same time what is it about. Another important addition is that there are also 2 additional variables. It's not clearly documented in the what's new. So now you have a way to create a dedicated listener thread per group and not be blocked by long-running queries. And to control the content of these 2 additional tables, there is also additional variable thread pool exec stats. When it's set, you have more precise information here. So the only useful reading that I was able to find out so far about this is the following commit that I linked here, so go for it. Finally, the analyze statement. I will not go into much details here. Thing is, now we have 2 measures of time spent. The table access time is reported separately, comparing to the time spent on checking the rows from the table, processing where clause for the table. So now time sums up nicely in the analyze statement for sub-stages, let's put it that way. To summarize, MariaDB added a lot of useful features for troubleshooting, mostly in the area of performance schema. For those using thread pool, and it should be all of us with many connections, there are also a lot of additional details visible in the information schema. Unfortunately, not all this stuff is documented, so I'm going to do it in my blog posts, and I hope it will be done in knowledge base as well. So it's work in progress, even though 2 minor releases of MariaDB 10.5 already happened. Thank you very much for attention. We are a bit out of time. My last word, as usual in all my presentations, is the following. Please report any issues, documentations, code bugs, your problems that you suspect may be a result of a bug in our public bugs database, jira-mariadb.org. Do as my wife did when she noted a nice bug. Just make a photo, make a snapshot of data, present it, and help us to make MariaDB better together.
Thank you, Valery Kravchuk. I see you have shaved, it seems. Now, to be serious, we have a serious case of network connectivity here, and I'm very happy that the presentation as such was done by the performance schema expert Valeri Kravchuk, but now we have a stand-in, Monty Mikael Videnius, and you're not such a big user or developer of performance schema. I'm sure you're more of an analyze kind of guy.
Yeah, so in my work doing development and looking at just why queries doesn't work, then analyze and doing debugging is more my thing. So I'm not expert in performance schema. But if you have a problem with a lot of queries running through and you want to know where time spent, then performance schema is a great tool in that case.
So when you analyze stuff, we had an earlier presentation here that you get a dump from it and you can turn it on and you can turn it off. What about performance schema? Is that something that should be constantly enabled or partly constantly enabled? When do you use it?
It depends on your site. If you have a site that has little traffic and you want to look at it once in a while, then performance schema can probably be on at the whole time. But if you have a very busy site and you need all the performance you can get, then you only turn on performance schema when it's critically needed, when you need to do analyzing. Because it can take anything from 1 or 2%. The worst case, I've said 30. It's not common, but it can happen.
Okay, and since what version do we have MariaDB with a performance schema? Do you remember?
That already from my SQL time, so it's a
very long time. But it just never caught your interest all that much.
No, it's an interesting way to ensure that it doesn't have any overhead when it's not used and minimum overhead when it's used. So in that sense, yes. But because I'm mostly working on individual queries, not a group of queries, so I never had a big use of it myself.
Okay, and then
Valerie, who is in support, who needs to look at the bigger picture, he needs performance schema.
Yeah, so you're probably not the right person to ask whether there are any bugs in the performance schema. Can you sort of trust it? Does it give the right answers?
So we do testing with performance schema for every build we do, even intermediate builds. And if there would be any drastic bugs in it, we wouldn't do a release. And because we're doing releases, one can be sure that there is no fundamental bugs on it. And if you're running a stable release, it should just work. I haven't heard any big complaints about it. But everything should be in Jira. So those who have issues can check Jira, but I don't expect people to find anything notable.
Okay, and so basically your line is that you're mostly concerned personally about ensuring that individual queries are properly handled by the optimizer, but the overall statistics that you get from performance schema can sometimes be quite valuable, and the overhead that it causes is very often so small that you can keep it on. Is that a fair summary?
For a certain amount of time, but it, of course, any module that you add increase complexity. So personally, I don't recommend people to use it in production with where you need every CPU cycle that exists.
Okay.
Otherwise, yes.
Good. Anything else you wish the users of MariaDB Server to know about the performance schema?
What I'm more is interested is what the listeners have questions about, because I can talk about anything, but I usually like to address the audience. I will be here from time to time, so the more questions we get, the better we can satisfy any viewer.
Yeah.
Both,
so on that,
for this talk and any other talk.
And on that note, housekeeping note, we have a very active discussion on Zulip. So now you, Monty, were roped into this just when we realized that Valeri Kravchuk could not have a video conference channel to us. So it's unfair to you to just ask you to look at the topic of performance schema on Zulip, but I can assure you, Monty, that there is such a topic, and we're doing quite a lot of interactivity. So you can then turn in, Monty, to any of these topics of all of the presentations here at the MariaDB Server Fest in Paris and also give your comments. So thank you, Valeri, for giving a great presentation. Sorry that it didn't work out with your connection. And thank you, Monty, for shaving the Valeri beard and being present as a backup. Thank you, Monty.
My pleasure. For later.
Our next presentation is by Valeri Kravchuk, Dynamic Tracing of MariaDB Server on Linux, Problems and Solutions.
Hi there. My name is Valeri Kravchuk and I'm a Principal Support Engineer in MariaDB Corporation. Today, even tonight, I'm going to present you a talk about dynamic tracing on Linux, in this case applied to MariaDB Server, mostly 10.5 and 10.3. In some examples, I present this from a small town of Vyshgorod, located near the capital of Ukraine, Kyiv. I work in support of MySQL and related products for more than 15 years already. Of them, last 4.5 years in MariaDB Corporation. Since I quit Oracle in 2012, I'm also a community member, a public person who writes about MySQL and MariaDB and speaks at various conferences. I write about MySQL and MariaDB in my blog, on Twitter, even on Facebook. I abuse all kinds of media, and I was eventually noted for this activity last year and got even an award for my bugs marketing and other writings. Before doing my MySQL support, I was a trainer and a consultant working mostly with Oracle databases, and from that time I've got a habit of creating a clear, simple, hope useful presentations full of external links. So whenever in any my presentation you see underlined text, it's clickable and it will bring you some new document that may be way more useful than presentation itself. Even though I work on MariaDB Corporation, in all my public writings and presentation, I speak only for myself. So a standard disclaimer of a kind is presented. My views may not be shared and may not be in line with recent corporation policies, so they are only mine. Do not take it as a direct recommendation or best practices for MariaDB Corporation or interpretation that they would necessarily share. It may not be the case. So speaking about tracing and profiling, there are different ways to do tracing and profiling for MariaDB specifically, and it all depends on two things: how much code changes you are ready to do, how much you want to be involved in the code itself, and the performance impact of the tools that you use. So to name just a few possible ways to trace, I'll start with the fact that you can basically use debug binaries. In debug binaries, in the large part of the code, each start of the function and end of the function is instrumented with debug macros that allows you to trace the enter to the function and the return from the function. And there are also debug printouts and key points inside some functions as well. With debug binaries, these debug outputs can be dynamically switched on and off at runtime with specific debug commands. The problem with this approach that was widely used at the early years of MySQL development, that was quite useful, is that you have to add this code into your source code of MySQL, and debug binaries are really slow, and when they produce a lot of debug outputs, they're even more slow, so it's not practical. A thing that works for seconds may start working for days. So it's not dynamic enough. Other tracing facilities are actually embedded in MariaDB and include extended slow query log, for example. There you can trace all the queries starting from those executed for 0 seconds. And for each query, you can write down how many specific row level operations were used, or had it tried to use temporary tables, had it tried to sort something, and everything. That's quite useful and show query execution profile in a lot of details. But again, it's written to disk, and enabling extended slow query logs for all queries will give you a huge performance impact, while still missing some details about the internal working of the server. More tracing outputs are available in MySQL and MariaDB, including show engine in DB status, show engine in DB mutex, if it's not yet deprecated. If we speak about InnoDB internal, some of them are presented inside the information schema with InnoDB tables there. For example, you can get some details about each buffer in the buffer pool, what page is there, how many pages are used, and everything. Again, requesting this information would give a notable performance impact, and it's just one of the details. A kind of a good balancing between details and impact was found by, I don't remember, probably Google initially, who created the user stat, later used by Percona and available in MariaDB as well. So at user stat, we have a key statistics on number of operations executed by specific user, by specific client connection, on specific table, or even index. It's a very popular profiling tool that can easily help to find out, for example, indexes that are never used for days and months, it's redundant. Or the most hot tables, speaking about the I/O. Well, actually, the first community contributed feature to MySQL back in 2005, as far as I remember, was implemented by famous Jeremy Cole, and it was profiled for queries. So the query execution was split into stages, and each stage was the time for each stage was separately recorded as a profile, and then you can show these profiles. It's still available. Show profiles allow a lot of details to be exposed about the specific query execution, why it's slow, at what stage most time is spent. Is it I/O, for example, opening table, accessing query cache, whatever. But it's also dynamic, so you can enable and disable it. It again does not provide enough details about other parts of internal server work. Performance schema that appeared in MySQL 5.5 was aimed to resolve this problem of show profiles and to provide an insight to all parts of the code that developers considered important to be shared. By instrumenting them, and that instrumentation was quite efficient. So the performance counters, time, and everything was recorded into ring buffers in memory, and re-recorded when the buffer is full. So it's quite efficient. And it's still used. Moreover, recent MariaDB versions, including 10.5, added a lot of additional instrumentation, including memory and everything, and it's more or less now at the same level as MySQL 5.7. So, beside that, it's normal when you use some operating system, MariaDB there is not the only software that requires profiling and tracing, so there should be some tools created by the operating system developers to work on their own kernel code to begin with. So there should be some way to trace the kernel, and there should be some ways to profile the execution. So you can see a lot of tracing and profiling tools provided at the OS level. It can be real profilers like perf in case of Linux, or profiling tools on Windows, or it can be profiling like additional tools for profiling memory usage, for example, or for finding memory leaks, or it can be ad hoc profiling tools based on just periodic taking of stack traces like famous PTPMP. The last but not the least, you can get a lot of insights of how MySQL MariaDB works by just capturing the traffic. via utilities like TCP dump, traffic on the wire. So this way you can capture the query and reply to the query, and you can see how much time is spent in between. And each network packet has a timestamp, so it's quite detailed, and it has zero impact on the server itself. So it's like a list of possible solutions. Of them all, I highlighted one that is specifically a topic for this talk. It's using auth level tracing and profiling tools. That's it. As we speak about Linux, there are 4 basic tools that I'm going to mention and speak about. First of all, the real trace interface appeared in kernel 2.6 about 11 years ago, and it's ftrace, function tracer. The ftrace appeared in a very easy way. The reason was that they had to resolve the problem in kernel, and it was an extension based on the idea of GNU profile. So when the program was built with profiling information, a special code was inserted at the beginning and at the end of the function, the same way as I explained in case of debug package of MySQL. And at these moments, data collection happened. So they extended this existing way to compile the code and added a way to dynamically replace part of the already pre-existing code with calls elsewhere. So, and then expose the resulting information via the files interface. That's ftrace. Then on top of ftrace, really soon, real profiler, as I called it, the best Linux profiler with the least impact, the most dynamic one, called perf, was added. And this was already a convenient way to add my favorite way of instrumenting the code for tracing and profiling, so-called dynamic probes. So it's possible for more than 10 years already for any binary running on Linux, including Linux kernel itself. We should use it for databases as well. On top of that, on recent kernels, starting from 4.9 specifically was already quite complete, and specifically with Linux kernel 5 and more recent ones, even better tracing tools with less impact, more efficient ones were added in the form of eBPF, or extended packet filter. BBBBB stands for Berkeley, surely. Actually, in frames of BSD, they re-implemented tools like TCP dump and packet filters in a way that to make them applicable not only to network events. And they did it later in Linux, re-implemented it again on top of a virtual machine that safely can run in kernel context and most efficiently collect the metrics in memory buffers, like in performance schema. So on top of eBPF, raw eBPF required programming and using the related API in languages like Python, for example, or Lua. Then on top of that, command line tools, so-called BCC tools, BPF compiler collection. So as soon as API were implemented, these tools were already written, and you can use existing tools, write your own. That's what a separate team at Facebook does, for example, where they use eBPF a lot. And finally, the last edition that is usable in kernels 5 point something, like on Red Hat 8 or recent Fedora and such, on recent, like few years old Linuxes, is BPF trace. BPF trace implemented a safe and quite interesting language in Aveka style that produces the program for that in-kernel virtual machines without the need to code in Python and use API directly. So you just script it, extended scripting language. So this is I am going to speak about these tools. Why not performance schema? There are 2 reasons. One of them is historical, and well, there are more, and I will present them. But most importantly, it's all about the performance impact. And another historical reason is being able to add probes dynamically. If you have to change the source code to instrument something, if instrument is missing, like it happened with performance schema, it's a serious deficiency for my work. I am not a developer. I am a DBA and support engineer. So I need a solution right now and here with existing code. I cannot wait for the instrument to be added. I needed to add it dynamically. That's it. So yet another reason why I do not discuss performance schema here is because it's discussed elsewhere. During this event, MariaDB Server Fest, I have another presentation explaining mostly the details of additions to performance schema in MariaDB 10.5. One may argue that performance schema is inefficient in a sense that it adds a lot of additional memory in server. That's true, and it's even more true in case of MariaDB. It changed a bit to better in 10.5, but in general, yes, you need to keep that memory buffers for every instrumentation point. It does not matter if it's used or not, until recently. In 10.5 and in MySQL 5.7 later, we have a dynamic allocations for memory for some instruments, so it's not that bad, but it's still not dynamic enough. One another thing is performance schema may not be even enabled or compiled in. It's not enabled by default in MariaDB. It's not compiled in some forks like MySQL at Facebook. And even if it's compiled in, it still may be not enough dynamic because some instruments up to this day can be enabled only at server startup. So if you were not there and had not an idea that you need this instrument enabled, it may be too late. You cannot check memory usage of the InnoDB buffer pool unless you asked to instrument memory at startup. That's it. Sizing buffers may be a problem, so that finding that trade-off in between size of the memory additionally allocated for performance schema versus the number of details and frequency of changes that you want to capture is a real problem. So with performance schema, you may spend a lot of time trying to size each instrument properly to get the smallest performance impact and still not missing the detail. Another thing that I hit that we cannot expect, while Oracle would like us all to add performance schema instrumentation everywhere, they cannot force it, and we in MariaDB cannot force it. So, for example, inside Galera library that is quite popular among MariaDB users, the amount of instrumentation in performance schema is quite small. And we can do nothing about it because it's third-party plugin. There are third-party storage engines, so we, again, cannot be sure how much they instrument. We cannot influence that. Yet another thing is, usually when you are troubleshooting, solving some problems, you approach them from two sides, from your software, from MariaDB server side, internally, and from the operating system side. You need to monitor operating system resources. If you use different tools to monitor and trace for your software versus operating system, you have to somehow summarize and put them all onto one plate and use together. So first of all, you pay the price twice for tracing at operating system level and for tracing at your software level, and then the results may not be compatible. So that's it. The last but not the least is the following. In MariaDB, we in support work actively and closely with developers. So when we report bugs or issues, we need to provide the information the developers asked us to provide. So they do ask us to provide stack traces whenever there is some hang or some slowdown or any performance problem. And performance schema doesn't give you stack traces. It may give you a set of stages, statements, transactions, everything, some insights following some functions in the code, but it's not a complete stack trace. So that's what we requested. We got requests for stack traces, so we need tools that produce stack traces. It's not performance schema. And for me personally, performance schema requires too complex SQL queries for many tasks, and as I often do not have them collected and prepared, if I need to invent it on the fly, it's too complicated and takes too much time. So what I suggest instead? I suggest to use modern Linux tracing tools. If we get to this picture of all the utilities that you can use to get performance information from, there are many, and most of them are probably known for you, from top to PS to free, SAR, and whatever. I am interested in this specific part: ftrace, perf, BCC tools based on eBPF, and BPF trace specifically. As you can see from this line on the picture that I borrowed from Brendan Gregg, they cover the entire stack, from the I/O to kernel details to applications, and with libraries, APIs in between. So you can trace everything with the same tool. That's the point. This approach is quite popular for maybe the last 5-6 years, and there are many famous people who are writing about it, so just follow the links. Now, what are we going to trace, and how do we approach the profiling? There are 4 types of event sources, so we will try to capture events. So there are 4 types of event sources that we might be interested in. They can be presented in such a simple table. So first of all, there are some events in the kernel. For example, if we are tracing and dealing with I/O problems, I/O is implemented by the kernel, so at some level. So we may be interested in what's happening at the kernel level. And there are event sources in applications or in user space, as I put it here. Now, from another dimension, it depends on pre-existing instrumentation that was in the source code of the kernel. Then it will be a kernel trace point, or in the source code of the application software. It's like what happens with performance schema probes, just they are not accessed by these tools. These are so-called user-defined statical tracing, userland statically defined tracing as well, simply dtrace probes. Based on dtrace in Solaris, that was the first dynamic tracing tools widely used and like a father of all dynamic tracing. We do not use Solaris anymore these days, and dtrace, while it's present in Oracle Linux, theoretically is not easily available outside. So kernel developers of Linux had to invent other options. So manual annotations mean that you have to change the source code, then recompile, and then you add event source. It's inconvenient and it's not dynamic. So another way is to add dynamic or automatic probes, and this is what we are interested in. So you can do it in kernel context, and it will be a kernel probe. Basically, you can add probe to any kernel source or function, or you can do it at user level. That's my point of interest for this talk, so-called user probe. So you can add tracing events dynamically to functions without changing the source code. That's the greatest way to do things. So, okay, you have event sources. Let's assume you somehow defined some events for your software, for MariaDB. How you can access the event sources based on the tracing framework that covers the entire system that I am going to discuss here. It's Linux, so it's Unix. Everything should be available through some files. So yes, you get access to event sources via the files in a special kind of file system, TraceFS, that can be mounted on sys or elsewhere. Here, let me finally go to the terminal, and here is what I'm speaking about. So we have TraceFS mounted here at syskernel tracing. So then we can just check syskernel tracing, what is there. Now the first problem that I'm going to mention with this tracing approach is that you need sudo or root access. So unfortunately, for developers who do not own the server they work with, it may be a bit complicated. But yes, that's what we have there, a lot of subdirectories, files, whatever. And they will be dynamically added and removed depending on what tracing facilities you do. So how do you deal with files on Linux? You read files and you write to files. So that's the basic way to deal with event sources. You can do it from command line, you can do it from the system calls. That's it. As a result of your writes to some files in this tracefs file system, the source code of the functions is modified on the fly to add tracing events. When you are done with it, you stop tracing, that instrumentation is dynamically removed. So you pay the performance price only while you are tracing. So you can add trace points dynamically and remove it when they are not needed. You can add them on the fly only for the period that you need. And you do not use neither CPU nor memory when you are not tracing stuff. So these files, numerous files, are not so easy to deal with, easy theoretically, but a lot of commands to type in practice or a lot of code to write. So we need some front ends. With time, when this dynamic tracing system evolved, on Linux kernel, several front ends were added. The first was perf, then BCC tools were added, then the latest one is BPF trace. They're all front ends. Front ends are truly optional. So as soon as we have the file system mounted, that's how it's mounted if you don't have it. We see some files there, we have seen that. We can check what is there as we were interested in dynamic user level probes. So let's check uprobe events. Tracing uprobe. Yes, so what is it? We can get access. It's a simple file. It's empty now, so there are no user probes. The file exists, but it's empty. Okay, so to add the probe, we had to write something there. Then it will not be empty. If you do not want to write something there manually, you can use tools based on top of these files, command line driven, that already simplifies this process for you. Let's skip it. And we can still do it manually. Let's assume that I would like to add a trace point, a probe, to the dispatch command function in the MariaDB 10.5. So the first problem that appears if I use ftrace directly is that I need to find out the address of that function relative to the binary. So because for the probe, I have to provide the address. Ftrace does not know anything about the source code, it just needs to know the address and try to do something with it. So how to find the address? To find the address, you can use the obj dump. There are different ways, it's just one of them. With T option, provide the binary and then search for the command. Here is the address, you can see. The function name is mangled because, well, that's the way it works. We may have to use mangled names later with other front ends. So with ftrace, we need just address. So we can add a probe, P. We can give it optional name. If we do not give a name, then the name will be inferred from the binary name and function name, or whatever. So we give explicit name, DC. The binary is listed here. The address is listed here. Then for dispatch command, we would like to print the query, which is the argument. The argument number 3 for dispatch command. Here it would be interesting probably to find out how do we know. We need to know the source code. We can study it, or we can use it and study with GDB. So we can attach GDB of MariaDB. I already used branded names. For 10.5, it's MariaDB. So if we attach to the binary, we can add a breakpoint, for example, dispatch command. So then if we try to, for example, connect to MariaDB, surely we have to continue here. Okay, so that's it. We started and we already executed some command. So our breakpoint fired, and here we have a query. We can see it as a third argument called packet. So here we can just print the third argument and see the query. It's asking for the version. So if we queue it from here, that's the knowledge we need to add dynamic event as well, user probe. So we detach from GDB, get back here. So that's what we do. We need it's a third argument. We should know how arguments are passed for our platforms for ftrace. Its third argument is passed by the register in the register that should be accessed as DX. So not extended, just DX, trust me. And I'm printing the content of the register. +0 is also important to get the address right, 0 terminated, as a string, and we give it a name of query. So if we write this text to the uprobe events, we can append it. Now we just overwrite, but if there are many probes, we have to append. And then enable the specific probe, and then enable tracing. We can then read the content of the file, some file. There are several, depending on what you trace and how you trace. For example, trace pipe and get the resulting query. So the idea of this test was to capture the queries on the fly. You can do it for 11 years already. There are details presented in my separate blog post. So you can access event sources and add dynamic probes with nothing but ftrace. You do not need perf installed. You do not even need GDB. All you need is objdump to find the address and knowledge of the source code. That's cool enough. So what are the problems? The first problem is already known. You need root access. How to get address? Well, objdump helps. It may get complicated, unfortunately, with C++ and other modern software, with Java, for example. I am trying to show some of the problems and solutions in a separate blog post. How to work with function arguments? Okay, if it's just a simple argument that can be used as is, as in our case, we just need to know how it's passed. But what if it's a structure? So eventually we can access any memory area. It's not going to be safe, but we can try. And well, probably we can figure out how to print structure as detailed as thread, for example, in case of MySQL or MariaDB. But it's complicated. So this tool works easily only for simple functions, ideally written in C. Then what if we would like to add the trace point at the end of the function? For example, let's consider allocate memory. If we want to trace memory allocation, we probably need to know the size of the allocation and the address that malloc function gave you back. So with this address, you can then store it somewhere and then trace also the free, and then you can see if something remains after some time of working, how much memory is allocated in total and everything. So for the probe at return from the function, there is just another type of the probe. It's R, return probe, and you can access readval. The return value from the function. Again, you can print it differently. You should know the data type. There are only a few basic data types supported, so it's all getting complicated. When you are done with the probe, you can just clean up everything from your probe events, or you can just remove the probe by name with minus. In more or less complicated cases, I had to, and that's my suggestion, actually use a front end like perf to add a dynamic probe and then check with the tracefs mounted how the probe looks like. That this way you can study how it's done. It's complicated, and I'm going to spend more time with months and years on how to do it with pure ftrace, because ftrace is always there. Some customers may not be able to install additional packages due to their internal security reasons, but they do have ftrace. So they may still have problems with root access, but that's another story. Then with no root, all this is not for them. So the oldest front end is perf, which is actually a sample-based profiler. But we will use it for adding dynamic probes as well. Perf basically, it has dozens of commands, allows to record the profile, to create a report based on recorded profile, to show the recorded profile data. Perf top is kind of top, but with top functions. It's interactive utility showing what spends most of the time based on your sampling. And actually the way to add a dynamic probe with perf is perf probe. What a surprise. So with perf probe, you can add similar probe to the one we already discussed previously with a much more user-friendly command, just dispatch command. Is a function we want to trace, and we want to print packet. We already seen it's a variable. It's variable name as a string. No mangled names, no addresses. That's it. Then we can start recording. It's sampling profiler. We can set up the frequency of recording so we do not miss any calls, or without frequency it will be picked up automatically. So we can do recording for some time, for example, until we stop it. And then we process the result with perf script, and then with this probe added, we can see the queries captured. That would be the output from MariaDB. When we are done with the probe, we can delete it by the name. So that's easy. The name of the probe will be shown to you when you create the probe. So you will see that the name is like probe dash binary name, short MariaDB D, and then a colon and actually a function name. The rest are optional parameters. So yes, we can see the queries. This way, moreover, we can also see the binary, process ID, CPU or core on which it runs. There is a time starting from the start of recording, so we can see how much time was spent on our probe. Then the probe name and probe arguments. There is also the address. So you can do a lot of things to control this output format. As it's visible from that simple example, it's way more user-friendly than ftrace, because you can use names, you can access, in many cases, you can access complex structures, records inside records with pointers and everything, not always, but often. And still, while it's more easy, you may have to study source code and do some checks in GDB to find out what exactly you would like to print. Problems. Are there any problems? Usually no, but for example, when I try to use this approach for MariaDB 10.3.18, as far as I remember, on my old Fedora box provided by Fedora, it was Fedora package, at that time, that same function dispatch command was implemented differently. It had a comData structure argument where the query was in comQuery point query. And when I tried to add the probe, it had not worked. I was not able to dereference this the argument properly. I had not spent enough time, and I decided on that and decided to go an easier way. There is another command in the stack for looking for the queries. It's do command, and at that version it had also the packet, and packet contained the SQL statement. So I tried to add it, and I failed. So whenever you cannot add the probe for whatever reason, you see it. So the packet was a local variable at that moment, and I was not able to access it. at this stage. I could access thread parameter, but it was too complicated, and I was not able to figure out how to do it. So what I did, first of all, I was able to check that theoretically in perf you can access all the variables. So yes, I was able to access the thread variable. That was the only argument for do command at that time, but I was not able to go farther. Next thing, that packet was a local variable that was available, and later, this is how it was declared, and it was initialized later. So there was a way, and there is a way, to add a dynamic probe. As you can remember from ftrace, it's added to the address. That address is not necessarily the beginning of the function. Actually, any executable command can be replaced by the interruption code int3, and then the probe can be added dynamically on the fly. So to find out which lines of the code can be instrumented, there is a line, not lines, sorry, it's a typo line command. So for the specific function, you can show a line that you can attach to. And of all the lines, I found out that line 157 is the one where the local variable packet is already declared. And it should get the proper value. So I tried to add the probe there. The syntax is quite simple. You add the probe to a specific line of the function. You can add the probe actually to a specific line in the source code file with another syntax, but similar. And I print a variable named packet as a string. And I've written down everything, started recording, and got my queries again. So what's the lesson we get from this? All this exercise was a result of the fact that simple command had not worked. But I found out that with perf, you can easily, it's a convenient front end, you can easily add a probe, dynamic user probe, to almost every other line in the code. And access local variables there. So it's the most dynamic way to trace things you can imagine. You can add the probe after every other line in the code, before it and after it. Give names and measure the time spent executing this specific line of the code. Not without, not with recompiling, not with adding performance schema instrumentation, not without waiting for anything, just on the fly, and it works. Besides user probe, you can surely use kernel trace point. For example, it's needed when you try to measure time spent on I/O, for example. You can do tracing not only for MariaDB server binary itself, but you can trace shared libraries as well, those that are dynamically loaded. This is how I trace malloc calls and size of allocations. This same approach was already applied by my colleagues in MariaDB to software called MaxScale. You probably know about it. So it's not even a server. You can apply it to anything where a memory leak was suspected. So all the details are already shared in a blog post. In another blog post, I've tried to apply it to C++ and was successful. That was a case of MariaDB 10.3. In 10.5, I found out that this member function became virtual, and for virtual functions, you are not even able to add a breakpoint in GDB. So you cannot trace it, or at least there is no easy way to do it. So these practical examples show you that problems are real. Not all of them can be avoided. Just a few words about perf as a real profiler. That's the first use for it for myself. Perf is easy to install. Perf is easy to use. For profiler, you usually, as it's sampling profiler, you usually set up a frequency. How often, how many times per second you want to stop the execution and check your trace points or capture the stacks. That's how profiler works, and measure everything. There are default frequency. It can be self-tuned by the perf itself. 99 samples per second is usually enough. Then you can record forever. The more you record, the more data are recorded. The data are sampled by reading from that tracing file system, and they are put into the user space. Writing files into the user space takes time and resources and disk I/O. So usually you do not profile for days, you profile for a short time. So you can profile just function calls, or you can also write down stacks. So with -G, you write down also stacks. You can profile specific CPU or all of them and many more things. So you record your profile. When you are done, you can, for example, stop recording the one way or the other. And you can get the profile. You can get it dynamically too. I will just show that for the, let me queue it from here. For some samples, I have a sysbench command running, and in another terminal at the same time, I can do like perf top. Yes, and you can see where most of the time is spent at the whole system level. It might take some time. The load is really high. The frequency is already decreased. So let it work for some time. As a result, if you are writing down stack traces, you will be able to get a tree of function calls with percentage for each. Oh, here it is. So we can see that, for example, most of the time is spent on Unix. A lot of time is spent in MariaDB. You can step inside, zoom into the thread. See, it's dynamically changing. So when you are done, you can queue it from it. Sorry. So I will not overload the machine while it's recording. So one of the basic examples from my blog post, probably 4 years old already, shows a case that turned me to dynamic tracing entirely. So the case was simple. At customer side, in a complex Galera setup, simple queries like select single line by primary key often hang for 13 seconds, for example. And the idea was to find out why they are slow sometimes, sometimes not. There was a lot of concurrent activity and everything. I tried everything I could with performance schema, show profile, and whatever. And I found out that a lot of time is spent at statistics stage. So calculating statistics. What statistics? Why? It was not clear why it takes so much time until I've got a profile with stack traces. Here's where the most of the time was spent. So yes, it was in statistics. We were reading the data from the table. You know, in InnoDB, when you need to find a plan for the query, and you are looking for the key, you have to find out how many rows you may get for this key. So it was really a reading of data from the table. And why it's slow, why reading one line is slow? It was waiting for in the QE to enter the InnoDB. The problem was really that in that case InnoDB concurrency was limited. So when there were other, for example, 12 queries for 12 cores or doing something for quite a long time, like doing big updates to unrelated tables, such a simple statistics request was blocked. So the resolution was simple, remove the limit, but I studied quite a lot on that. Among things that I studied was that performance schema is not detailed enough. Performance schema does not document stages of statistics calculations and many more things. But really, dynamic tracing and using perf profiler was a solution to a real practical problem after everything else had not worked. And the detail was missed surely by me, and everything depends on the load. Under some load, everything works, then it does not work. So we try to capture the statistics for and the information for quite a lot of time. In practical cases, the call stacks and such graphs, they may become huge and not easy to work with. The samples collected themselves can be huge. So when I was collected I/O requests at kernel trace point for 60 seconds, it took 33 megabytes. Writing 33 megabytes on some hardware may be already time consuming. So, to summarize, what are the main problems and challenges if you have root access and you mastered the tool? There are two. First of all, perf at the front end that writes everything to the user space is having too large impact. What is the solution to these problems? Use a lightweight tools. So if it would be possible to process the data, not after the fact, after the collection, but on the fly, that would help a lot. If that would be possible in the kernel context, without touching the user, and passing to the user only the result that is needed, that would be perfect. And ePBF gives us that. And another question, what to do with such a complex profiling information when it does not fit on many pages on screen? So you have to summarize it somehow. The answer to this is post-processing tools. Of them, the most popular right now are flame graphs and other heat maps. So you have to summarize and visualize this data in a way that are easy to use. That's a bit beyond the topic of topics of this talk, but you will see how it looks like. So, as a way to reduce the impact and trace safely and summarize safely whatever you need, eventually eBPF was developed. When porting dtrace proved a hard task and stalled. eBPF is based on backlink packet filter that is behind TCP dump. The idea was that filtering should be executed at kernel context, so efficient, but it should be safe, so it should be in some virtual machine. So they had rewritten the code to run in a virtual machines that was efficient because the code for it was JIT compiled, just in time compiled to the machine code. So there was an extra level of safety, there is an extra level of verification before the code is allowed to run in eBPF virtual machine, and for this eBPF to be useful not only in network stack tracing, it was provided access to kernel probes, user probes, static trace point in application sources, performance events, and almost everything. Same as performance schema, eBPF writes down to the memory areas in kernel. And then these memory areas can be read by end user. So it's as efficient as performance schema. Maps are limited in size, so memory is also not abused. And you have access to all the internals in the kernel. And you can summarize things in the kernel. So more or less up to the kernel 4.9, all this machinery was implemented, tested, and widely used. So the problem was with front ends, how you write the code. You can write LLVM, it's LLVM virtual machine actually. You can write assembler code for LLVM, but it's too complicated. So there were APIs ported to Lua and Python, and at this moment people started to create a lot of tools in Python doing all kinds of things. For example, access to dtrace static trace point that some software still had supported. So it's like people decided to stay dtrace compatible when they implemented different previous tracing frameworks for Linux. So we can, for example, do that same thing as we did printing queries on the fly using a static trace point if it's defined. So that's how it works. I should say that MariaDB binaries do not provide dtrace, and MySQL 8.0 just removed dtrace probes entirely. Fedora conveniently had them compiled, so I was able to capture the queries this way without anything else, just by using a ready-to-use BCC tools and already existing in the code static trace points. So the same way with trace, you can add with similar tool called trace, you can add dynamic trace points. You will still have to use mangled names. You need to know how arguments are passed. You can see it in my blog post how it works. So you can write your own BCC tools code in Python if you're a developer, and entire teams, as I said, in Facebook, for example, That's their main job, to write such a code. If you're a DBA or a support engineer like me, not a developer for decades, if you do not have Python installed, you may still write down quite efficient custom tools to summarize the information provided by the kernel using the newest front end called BPF trace. So it does not work, for example, on the machine I am currently working on Ubuntu 16, but it's really old. Whenever you have kernel 5, you already should have a working BPF trace. There were some problems on Fedora 29. Starting from Fedora 31, they are mostly resolved. That's based on my experience and what I was told. How BPF trace works? You can actually study the tutorials, but basically you provide a program. It's like AWK. So the program looks like you have a pattern. If something matches the pattern, there is an action. So it's a set of pairs pattern action. So if you see something, you do this. As an action, you do not have loops, unlike in AWK. So there is a guarantee that BPF trace program always complete. It cannot hang, cannot loop, cannot hang the kernel virtual machine. So you add the trace. You basically add the trace point. For example, syscall, sysenter for all of these. For a specific syscall, like here. So it's a pattern. So whenever we see this call, we do print the arguments. So these are open files, for example. So basically, that's it. You define several probes. Then you can match additionally the probe against some filter, and then there is action in curly braces. So how it may look like in practice? Besides trace point, BPF trace is also able to act as a profiler. There is a special probe called profile. You can set up frequency, same as with perf. You can add a filter. For example, you do not profile the entire system as we did with perf top. You profile only MySQL-D, for example, or MariaDB-D. And then what you can do, you can print user stack, in a perf compatible format. There are two kinds of formats, and you collect stacks same as we do with perf profile. Here is the content. So we do calls, dispatch command, do command, everything. Thread pool was active, so we have a callback here. So you can check my blog post for details how to use this in practice to have both user space trace and kernel space trace sampled 99 times per second. This is how it works. Why should we care? Why should we bother? Because of the performance impact. So with eBPF, no matter how you access that, maybe by BPF trace, you have the smallest performance impact. I was running similar sysbench test on another system, and I've checked the queries per second executed with different dynamic tracing options. PTPMP, poor man's profiler. So we got a drop to just 56% when we collected once per second and missed many samples. If we try to collect more often, just all hands. With perf record, we had 98% of queries per second, so there is some performance impact, mostly related to writing down this amount of data. And with BPF trace dynamic profiling probe, when I've counted, similar to what we did above, I've counted the number of unique stack traces. So I've got just 0.13% of negative performance impact with 99 samples per second. With higher frequency, it will be much worse. Few words in conclusion on how to represent the data. You can read a lot about the flame graphs. All these tools, dynamic tracing tools, their output formats are taken into account in this set of tools developed by Brendan Gregg, so you can process stack traces from PTPMP, from perf, or you can pre-process whatever stack traces you see. You can use BPF trace directly. You can use pre-existing, pre-built Python-based BCC tools. For example, if we try to find out where the time is spent, if it's not on CPU, we can use the existing off-CPU time utility, produce text, then collapse them and present them graphically. We see where most of the time is spent here. Let me summarize the problem of dynamic traces as we are going out of time. So, first of all, you need root or sudo access. In some cases, you need literally root access. As I see from my experience, and as we could see maybe from samples I will share during the chat with you, there is a problem to debug the problem of the program when it is traced. So GDB sees a different code than it expects. It does not really work. So it's still a problem to find out the amount of additional probes and the trade-off in between the details you collect and the amount of memory and CPU you spend on collecting. Adding dynamic probes to C++ and complex code of that kind or to Java may be problematic. Using BPF trace to access source code may be more problematic than perf because you have to pass headers. It needs to know structure. Surely for all of this to work, you have to build with a no omit frame pointer. If we cannot get the frames, we cannot get the information. In case of pre-built packages, we may need debugging for packages so that symbolic information is available. In some cases, we have more tools to install, but with ftrace, it's always there. The most important with all tools above and beyond perf is a lack of current practical experience. It's my own problem as well. I had not used them often enough to really be fluent with them. But I'm still not the only one who is suggesting this stuff. People do dynamic tracing even for Oracle or DBMS, and you can find out a lot of other additional sources of information about this. So that's all from me. As usual, if you ever see a bug or a problem in MariaDB, report it. Thank you very much.
Thank you again, Valery. Another great presentation. We have another great Valery stand-in, growing some beard since last time. So hi, Valery stand-in, Vincenzo Ciorbaro.
Hi, everyone.
So I first want to thank everybody who has made this possible, that we have a safety network here. So we do have a couple of hot standby backup nodes here that can run in. Last time when Valery's connection failed, we had Monty, but now of course we knew that that's going to be the case. We will not have a Valery answering all the great questions live here. Valery has been answering over Zulip, and the chat on Zulip is very productive and good, so very good with that one. But Valery has also been filling in you a bit, Vincenzo, so that you do know some things that Valery would have wanted to answer, don't you?
Yes, for sure.
Yes. So I'll also have to say that Valery works for the MariaDB Corporation in the support team. You, Vincenzo, work for MariaDB Foundation, and you do not do support. Hi, Monty, in the background.
Yes.
So you do not do support. I suppose that this is a great thing to have in support, this particular trace feature. Is that what you've been told by Valery?
Yes. So the trace feature is very useful, especially when you have a system that you cannot just play around however you like. So you're at the customer, you don't have a choice of, okay, can you please install this MariaDB version now so I can give it a try? So instead, you have to rely on the tools you already have, and that is what perf and, in this case, dynamic tracing could help with. Now, the problem is that when you have to rely on dynamic tracing, that's kind of like the last resort. You can't really do it.
What did you do beforehand? You say it's the last resort. I think, yes, it was cool what Valery presented, and I was in awe. and I really liked it, but I also wouldn't want to do it to fix every bug. So what comes before?
Well, before you always have the basic tools like let's analyze queries, let's have a look at the performance schema if it is enabled. You can just try and use your best DBA knowledge. Do I need an index here? Is this data type something that I'm familiar with, that it takes a long time to compare to something else? So maybe we should try and adjust our schema or fix our queries. But every now and then, you do hit a problem that could come from the server's code itself. So it may be that you've done everything you could. It's just that there's not enough performance for your use case. So that's when you need to start investigating. For example, Valery has told me that he's investigated memory leaks, not in the server itself, but in max scale. Now we have a similar problem in the server. We just recently started finding ways to fix it. So if we have a memory leak, it's rather hard to trace where the leak happened.
Right.
And we have something that's very similar to dynamic tracing built inside the server. But again, this is code we have to write now. And dynamic tracing is a way to produce that code out of thin air. You basically have printfs wherever you need them, for example, in my malloc.
Yeah, so you get basically, as I understand it, the opportunity to insert a printf more or less anywhere. Is that the case?
Yes, that's probably the most useful thing you can insert, but you can do other things as well. You can run any code that you really want to run. So the other advantage is that although the server might have a way to give you like a list of functions that were called one after another. That's what we call a trace. So this has very strong performance implications, and some problems you cannot reproduce with this sort of approach. Some race conditions only happen when you have a release binary, not a debug compiled binary. So whenever that's the case, just tracing it with our inbuilt system is not an option.
Yes, so as I understand it, this is sort of putting trace without a debug version being actually there. So it sounds like magic to me.
It is black magic, and that's why it doesn't always work. You are relying on a certain structure for the code. So if the compiler decides to optimize the code differently, whenever you set a trace point, it might not exactly go as you planned. And the compiler can do very strange things. For example, at some point I was debugging a release binary, and I was looking at the member function call, and somehow it ended up being in a completely different object than what I expected. Mm-hmm. And the compiler did this because the function had the same logic for both objects, even though they were completely different. So it completely removed one function, declaration, definition, everything, just because it could reuse the other one. So setting trace points in these sorts of conditions is not always guaranteed to work. That's why I said it's a last resort, but it's a very welcome tool to have when all else fails.
Okay, those are, I think, good insights and good summary points of what Valery said in his original presentation. So what about war stories of heroically applying this? Did he share? You mentioned that there have been cases where within max scale some of that has been solved by his support team. Did he mention any other war stories?
Well, Valery mentions all of the success stories on his blog, so I do recommend the audience to check out his blog here. One other thing he mentioned is that it's very hard to trace C++ function calls, specifically because of the process called name mangling. So only C++ has that, whilst the C does not. So he tried to trace C++ functions. He did succeed eventually, but it is much harder. So you can find lots of details about this on his blog post. And Valery will probably post it on Zulip very soon.
Yep. So on Zulip, you have direct access right now to Valery, asking him any kind of questions. that type of connectivity he does have. And then there will be a rerun of Valeri. So I'm reminding everybody that this is a 3-day and 3-location type of event. So if you have friends and colleagues in other time zones, this will reoccur in New York starting tomorrow, and in Singapore and Beijing starting Friday. And I also remind everybody that each of the talks in this conference doesn't only have a topic at Zulip, but it also has a unique URL. So this URL has had the abstract for a while and has the exact times when things happen. And it will also contain pointers to PDF files. So if you want to access any of the resources related to a particular presentation, just go to the URL. It's linked from our session list, and all of that is at mariadb.org/fest2020. So with those words, I want to thank Valery Kravchuk primarily, and his proxy stand-in, Vicente Ciorbaru. Thank you. The next presenter is from China, Li Shunpeng, a user story migrating from Oracle to MariaDB.
Hello everyone, my name is Li Xunpeng from MariaDB Foundation. I'm living in China. Today I want to introduce a use case. A China company migrate one of their application from Oracle to MariaDB. We just done the modified MariaDB version for this user last week. The application is testing in this modified MariaDB version without any application modification. This is my agenda. First, I want to introduce the background. Why the user wants to move to MariaDB, and then I will introduce how we got it step by step. The first is about the user requirements. This user case is driven by Hangzhou WatchTech, which is a MariaDB partner in China. The customer has some legacy applications using Oracle. The business logic is not complicated, and the workload is quite stable now because so many years. But they still need to pay an expensive Oracle license fee for these applications. So the customer decided migrating to open source database. MySQL ecosystem is the best choice, but the application is developed by ISV and is too old. The source code has been lost, so modify SQL is impossible. The only things we can do is to replace the JDBC driver from Oracle to MySQL or MariaDB. We need the database to be able to run Oracle queries directly. Why this user choose MariaDB finally? First, the customer decided to choose the MariaDB MySQL ecosystem because they consider this is the best open source database ecosystem. Lots of third-party tools, lots of technical documents. Many engineers are familiar with MySQL and commercial support. Then the question is MySQL or MariaDB? Why customer and WatchTech consider MariaDB is a better choice? Let's have a look about Oracle compatibility between MySQL and MariaDB. MySQL doesn't support most of the Oracle syntax and most of the Oracle data types. Migrating from Oracle to MySQL requires lots of changes to MySQL. We consider which is a huge project for years. And MariaDB already supports many Oracle syntax and data types, includes some PLSQL with Oracle SQL mode, and MariaDB already has an Oracle syntax tree. It's easier to add a new Oracle syntax support. So based on MariaDB is the best choice. Then how migrate from Oracle to MariaDB? The first, we should check the connection way, because not all connection methods may modify to connect to MariaDB. The second, collect the queries of applications. The third, analyze the compatibility with MariaDB. The fourth, evaluate workload for modifying MariaDB code or application code. Sometimes, if you are lucky, the application can modify the queries or change the application code. Then you needn't to modify database source code. The fifth, adding Oracle compatible code in MariaDB. In this case, we are unlucky that the application can't change anything. The sixth, testing the modified MariaDB version in application to verify everything is compatible now. Okay, let's see these steps one by one. The first, check the connection way. If the application is connecting Oracle by JDBC or ODBC, then it's doable. We need only replace the JDBC driver to MariaDB. But if the application is using native C OCI lab, then we have no way to replace it now. The good news is WatchTech can support Oracle OCI Podcom in Reno proxy product at the end of this year. Okay. The next, collect the queries. It has many ways to do this work, like enable Oracle SQL trace, use $v$ views, like this view $v$ circle array. If you have a proxy, you can collect all queries in proxy layer. If you are lucky, the application is using the SQL framework like Abatis, then you can get all queries from it. The next, analyze compatibility. Sequence is a good project. Is a good open source project. It can help us to analyze if the queries can rewrite to another database or not. WatchTech has its own set of tools to analyze whether the queries collected from Oracle can be supported in MySQL or MariaDB. Alibaba Cloud also has a tools named Adam can do this analysis too. And then we need to evaluate workload. MariaDB has done a lot of Oracle compatibility work, like virtual2 and number data type, sequence filter, and many syntax compatibilities like from DUL, Oracle style, query procedure, and function. except the MariaDB already done. For this case, we still have some compatibility work needs to do. For DDL, the Oracle has enable keyword, which is default behave in MariaDB and count chain. So we can ignore this keyword in query table and index. For DML, the sysdate function in Oracle needn't brackets, but MariaDB requires it. We can modify syntax tree to remove it. About 3 tasks are very easy. Modify syntax tree can solve it. And the Oracle has the toChar function, can convert the other data type to a string. In MariaDB, most of the time we needn't to convert them manually. MariaDB can automatically complete this work, such as between numbers and string. But for data type, we need to use data format to format it. This task is a little more difficult, but we can reuse the MariaDB internal functions. But we still need some changes. The most difficult work is row number. MariaDB can't support it at all, and we can't find the similar function. Sometimes it looks like a limit, but more complex usage. According analysis and evolution, we know which parts we must modify the code. Then let's do it. For task 1 and 2 and 3, it's easy. Modify circle YARC file can done these works. It's quite easy. Just add keywords so that the syntax tree can recognize them. We can see. Okay, we can add the enable keyword after the fulfill the definition, and also we can remove the break side for sysdate here. So we can see after adding the keywords and alias, MariaDB can run Oracle SQL now. For task 4, we can reuse the data format function to solve it. SQLines provided a table of mapping the format specifiers from Oracle to Oracle toChar function to data format function. Modify the make data time in item function file to support the Oracle format specifiers. In the same time, add toChar function keyword in circle YARC file here. Then we can see MariaDB can support Oracle toChar function now. The most difficult is task number 5, row number. How we implement the row number feature? ID row number. Our idea is ID row number as a virtual column based on MariaDB virtual column, and then adding a counter named current row number with default value is 1. When a row be read, set the row number field value to current row number. When row sent to client, then current row number plus 1. So if the query hasn't the while case, the current row number is the read sequence number. If the query has the while case without the row number, the row number field will return the sequence number after order by or aggregation. If the query has while case with row number, if the condition is row number greater than 1, it will not return any data. This is the same in Oracle. Once the result set from subquery contains the row number field, we will not add a row number virtual column again, which is the same with Oracle 2. After we have done these changes, we have solved all known incompatibilities. Then we can test the modified MariaDB in users' application. The first, we export and import the table structs and data from users' Oracle database to our modified MariaDB. Then start a test application to connect our MariaDB. And then to verify the application is running well, copy online workload to MariaDB through network traffic copy, and verify the MariaDB can support the online workload. Okay. Finally, let's see the progress of this project. This project kicked off on July 7, and we got the POC version on September 11. Although this application is not complicated, but the progress is based on MariaDB is so fast and beyond our imagination. Okay, this is all my presentation. Thank you.
Now for Scaleflux and Seth Shellnut, MyTile, a cloud-native storage engine based on TileDB.
Hello and welcome to the session on MyTile, a cloud-native storage engine based on TileDB. My name is Seth Shellnut. I'm the Chief Technology Officer at TileDB. Before we get started today, I'd like to say a big thank you to the MariaDB Foundation for putting on ServerFest 2020. I know the pandemic has changed the plans of the usual MariaDB conferences, and we're very appreciative of them getting this put together. Today we're going to talk about what is TileDB, an overview of MyTile, the use cases of MyTile. We have two use cases we'd like to highlight in particular, and the internal usage of MyTile at TileDB today and how we use that in production. So what is TileDB? TileDB is the universal data engine. It's built upon a multi-dimensional array format, and this enables storing and accessing dense arrays. This could be images or video, sparse arrays, which can be things like LiDAR or genomics data or others, data frames, which is really any data in tabular form, most commonly SQL tables, and these are most commonly stored as sparse arrays, and also key value data sets, which are typically stored as sparse arrays also. So when we say universal data engine, we're really talking about a whole number of tools and integrations and details about TileDB itself and the format and the core library. So the TileDB core library is this multidimensional array store, and you can store any highly structured data in the TileDB format, and you can efficiently slice and do and perform computations on that data directly in the cloud. We have a number of efficient integrations with TileDB and APIs that are in Python, R, Java, C, C++, and more. We also have a number of efficient integrations with things like Dask and Spark and PrestoDB, and of course MariaDB, which we're going to talk about today. And this efficient integrations and APIs allows users to analyze their data with any tools that they prefer. If you are trying to use some Python machine learning packages, TensorFlow or Keras or something, you can use that directly with our Python API, or maybe you want to issue a SQL query via MariaDB or use PySpark. The options are completely at the user's disposal as we provide efficient integrations for the whole package. We also have a SaaS offering, TileDB Cloud, which expands upon the universal data engine and enables planet-scale sharing of TileDB arrays and data sets beyond just your organization, but to the public at large. And we also have a number of hosted components to TileDB Cloud to eliminate some of your deployment hassles. Hosted Jupyter notebooks for easy exploration, scale-out computations via serverless user-defined functions in languages like Python and R and others, and serverless SQL, which is built upon the MyTile storage engine, which we'll talk a little bit about later in this presentation. So some of the core features of TileDB and the format itself are it's cloud native, so you can store your data in S3 in Google Cloud, Azure Blob Store, along with things like HDFS, POSIX file systems, and more. We have a unique tiling and chunking format that provides fast slicing on your data and atomic I/O operations. It's a columnar format, so all of the fields and attributes are stored as independent files. We have a multitude of compression, encryption, and checksum filters, things like ZSTD, LZ4, and more. The entire library is built around fully multi-threaded implementation using modern C++ standards. We support massively parallel I/O operations, which works fantastically well with the cloud object stores. We have data versioning built directly into the format itself. This provides rapid updates and time-traveling capabilities. TileDB also supports arbitrary metadata on arrays. These are key value stores where you can put any type of metadata about an array on there. You can also have groups of TileDB arrays, and this entire thing is packaged up into a very nice embeddable C++ library. So some of the features about TileDB itself that I want to kind of dig into before we talk about MyTile are things around time traveling, and the MVCC design that allows that. So to start with, every write in TileDB is immutable. Every write goes to a new, what we call fragments, and new objects are created. And updates are treated just as writes. They're completely immutable, and new files and fragments are created. And this is very important for cloud object stores where objects are immutable and you're not allowed to update single bytes. This also provides a number of benefits, time traveling being one of them. So if we look at the diagram that we have here, we have 3 writes that occurred. At T1, we wrote the 4x4 array. At T2, we wrote a subset. And at T3, we wrote a very sparse subset all over the place. After T3 occurs, the logical view of the array has all of the updates dispersed within it as you would expect. The power of TileDB and the MVCC design, though, is you're able to time travel and go back to any of the previous timestamps, T2 or T1, and open the array and access the data at that point and see the array as it was at that point. So if you open it up at, say, for instance, T1, you get to view and access the original data of the array before any updates were applied. Now, this object immutability is also very important with the crash safety of TileDB. So we'll talk a little bit more about the acidness in a moment, but you're crash safe based off this immutability. If a write fails, that fragment and that timestamp is simply ignored in subsequent reads. Now, a little bit of a technical note I want to hit before we move on is we do have something called consolidation supported. And as you expand this out, you can see that if you keep these timestamps over time and these fragments over time, there could be quite a lot of them. So we do provide the ability to combine and consolidate the fragments into a super fragment and purge out the history if you desire. This can reduce the disk space and can also potentially improve the performance. It's a complete optional feature. It's up to you, the user, whether you want to perform this consolidation and purge out some of your history or not, and then we or not. So TileDB supports the immutable objects, and that leads directly to our ACID support. So all writes in TileDB are atomic. I mentioned previously we have a tiling structure and a chunking structure. That gives us the atomic I/O units that we are able to write. Consistency is determined by the storage location. So TileDB, supports object stores, which are eventually consistent. We also support, POSIX file systems, which do support atomic operations there. With the eventual consistency of object stores, that's natively handled by TileDB. TileDB will always return valid results. We will never return corrupt or invalid results for a query that's given. So the eventual consistency is built into the format. No external service is needed, or external libraries or plugins or anything is needed to handle that. It's built into the format in that MVCC design. Isolation and durability is inherent in the MVCC design. Since every write gets its own fragment, which is basically a folder or a prefix, there's no collisions. Every fragment is unique with a timestamp and a UUID, so there's no collisions that occur between two writes. Transactions and locking are simply not needed for TileDB, and you get the full multi-reader, multi-writer design without this. Conflicting writes that happen at the exact same timestamp, while how unlikely do occur, those are handled natively by the UUID, and the ordering of that is based off the UUID. So let's talk about MyTile for a minute and go into the details about the MyTile, the storage engine based on the TileDB embedded library. Now, one of the big benefits of MyTile is it inherits all the functionality of TileDB itself. So it uses the embedded C++ library, and now you can natively access through MariaDB TileDB arrays that are stored on remote cloud object stores like S3 or Google Cloud. We support full dynamic discovery in MariaDB, so you can simply run a query such as select star from an S3 path where a TileDB array exists, and it just works. It just works. You are able to query the cloud object store natively directly without creating tables or moving anything or doing anything but issuing a select statement. And we have complete interoperability with all the existing TileDB arrays and other APIs that we offer. The MyTile is based on TileDB itself. There's no semantics. There's no difference in the actual storage format itself. It is the actual TileDB arrays that are accessed and used directly in MyTile. Now, I do want to make a note ahead of time here that the MyTile storage engine is currently maintained by TileDB Inc. It's outside the MariaDB source. We are hoping to upstream that soon. Now that MariaDB 10.5 is out, big congratulations to everyone getting 10.5 GA'd. We're hoping to work to upstream that soon. So there's a number of features and optimizations that we've done with MyTile to work closely with TileDB to offer a lot of performance and benefit for the large workloads that we're targeting. We're targeting a lot of the large OLAP style workloads where you want bulk access, bulk writes, bulk reads to do large aggregations and things like that. So one of the first things that we did was support condition pushdown. So we do support the indexing and primary keys that you would expect based off the TileDB dimensions. However, we also built in support to MyTile for condition pushdown, and this provides an increase in performance for a large number of queries. The MariaDB Query Optimizer does a fantastic job, and it's a great piece of software. However, there are certain cases where the optimizer might choose not to use a certain index or might go a different route. And because we know that TileDB can handle certain predicates on dimension fields very efficiently, we intercept those predicates where possible and push that down and those operations down to TileDB to do more performant accessing of the data. Besides condition pushdown, we also optimize with multi-range reads, and this allows for high performance joins between TileDB arrays through MyTile and other tables in MariaDB. They could be InnoDB tables, they could be other TileDB arrays, but basically the MRR support gives us this bulk key access, which allows us to very efficiently and very performantly query the TileDB data to fetch the relevant parts that are needed in bulk to do that join. Let's also take a moment to talk about transactions and the locking support in MyTile. So as I mentioned, TileDB is a lock-free system for multi-reader, multi-writer. The TileDB storage engine and format itself natively handles the conflicts with the fragments, and so there's no need for any locking inside MariaDB. So MyTile itself does not implement any locking, and you get a completely multi-reader, multi-writer experience as you would outside of MariaDB. And without this locking, we still support all the ACID-like functionality that TileDB natively supports. And so you do get the eventual consistency of cloud object stores as kind of the main limitation and full ACID compliance there. But without any locking or transactions, you do get the same guarantees that exist outside of MariaDB with TileDB itself. Now, transactions are supported only for bulk insertion of data. So if you are inserting multiple records in a single transaction, that is supported, and those records will be collected and then committed at the final commit for a bulk insertion. However, no general transactions are supported, and the rollbacks and advanced things like checkpoints and whatnot are not supported at this time. TileDB itself does not have transactions. It does not need transactions for the ACID-like support that we have. However, it is on our roadmap to consider MariaDB single server transactions and add some level of support for that. And then also we are looking in the roadmap to add some sort of orchestration layer or something for TileDB itself to support a level of transactions, as there are some edge cases where users might want those. Although, like I say, for most of the use cases, the multi-reader, multi-writer MVCC design of TileDB gives you everything you need and would expect from the general transactions. So one of the super cool things and things that I'm really excited about with MyTile is the usage of MyTile with the embedded MariaDB instance. So MyTile can be built and bundled into a single library with the embedded MariaDB instance. And we have customers that have used this, and we promote the use of this to facilitate exploring the data and do lightweight manipulation of your data. It works really great in combination with like a Jupyter Notebook to be able to access a TileDB array that's stored on a cloud object store without having to spin up a MariaDB server. So right from your laptop or right from a remote server in a single Python environment or other environment, you can query an array with SQL without having to spin up a remote server. And the MariaDB embedded library is fantastic, and I know it doesn't get a lot of love in the community and not a lot of people use it, but it's really a fantastic little piece of software and mode that it can be compiled in, because the MariaDB library effectively has the same API as the MariaDB C connector. So you can drop the embedded library into a number of clients, such as one of the Python clients, you can do the Java client, the R client, anything that links against the MariaDB C connector, you can drop the embedded MariaDB into, and then get SQL queries working on TileDB arrays without needing to set up a server. Now, of course, there are some limitations of the embedded MariaDB instance. You're having to fetch the data to your local machine where it's running, and you're constrained by the resources of that machine. So if you're working on your laptop, you might be pulling data across the internet, and you have limited RAM and CPU resource. But we do think that it provides a lot of benefit for initial data exploration and lightweight usage. I want to take a moment to discuss backups with MyTile. So TileDB arrays are self-contained in the folder where they exist, or the prefix on an object store, and you can simply copy that folder. The array is always in a consistent state, even in the middle of a write. The MVCC design, we use special OK files to signal when a write has completed and when they show up with the eventual consistency. So at any point, even in the middle of a write, it's safe to copy the entire folder out or copy parts of the folder, and you won't risk any corruption of that backup. Only potentially an incomplete write that might exist. So this opens the door completely to the hot backups and incremental backups in a very, very simple manner. The structure of a TileDB array is very straightforward, well documented in the spec, but it's very straightforward even if you just list it yourself. And this opens up the possibility for you to make an initial copy of an array and then incrementally only copy out to backup the new fragments and the new parts that are written. TileDB arrays work fantastically well with tools like rsync or the AWS S3 sync commands or the equivalent Google and Azure commands. So it's very easy to copy the data sets around and have consistent backups. So we've talked a lot about what MyTile is, some of the features, and some of the optimizations that exist. Let's talk for a minute about what it's not. So MyTile is not a general replacement for InnoDB. It's not geared toward the general transactional data sets and the highly transactional data sets that InnoDB supports well. InnoDB is a fantastic general storage engine that's been around for quite a while and has great support. And MyTile is more geared toward the OLAP in the large data sets, the terabyte sized data sets, than it is for the highly transactional data sets that InnoDB does. Also, MyTile is not designed for full text search and indexing capabilities today, such as for storage engines such as Runga and others that are more specialized. TileDB gears more toward the general OLAP use case that exists. So let's briefly do a quick comparison between InnoDB and MyTile, and then we'll also look at MyRocks and MyTile. And to start with, I want to say this comparison obviously is at a high level. It's not complete. We're happy to discuss in more detail some of the comparisons after this session. Some of the advantages that MyTile has compared to InnoDB, of course, is first off, it's cloud native, so you can store your data on S3, Azure, Google Cloud, full read-write support, and you're not limited to the data directory of MariaDB. Of course, you can write your array to the data directory. You can write it to a local file system or anything that we do support. There's also a large number of compressors that are supported by MyTile, ZSTD, LZ4, run length encoding, and more that InnoDB don't support. There's also significant reduction in write amplification. So we do not have a redo log or an undo log like InnoDB. So MyTile has a much less overhead for the write amplification that exists. We also natively support the time traveling without the need for system version tables or any outside libraries or tools to support that time traveling. And we also believe that compared to InnoDB, we're going to have much better performance at the terabyte scale. That large data sets are really what we target with TileDB. Although TileDB scales, from kilobytes to terabytes or petabytes, compared to InnoDB and the general use cases, we're really targeting the larger data sets. Now, there are some disadvantages of MyTile, of course. InnoDB is very mature, very battle-tested. Like I said, it's been around for quite a while, used in probably millions of servers worldwide. So InnoDB has been around quite a while. InnoDB also has great support for replication and backups through tools like Maria Backup, Extra Backup, and Galera for cluster-type environment. And InnoDB also has significantly better single record insert performance. Like I say, that transactional workloads that InnoDB really excels at, that we're not really geared MyTile toward. Now, of course, with these disadvantages, MyTile does support single record inserts. We've talked about how to do backups, and we do use MyTile in production today. So the fact that it's not quite as mature as InnoDB does not prevent anyone from using that in production. But InnoDB does have certain advantages for certain use cases, for sure. Now, Let's compare it to MyRocks. MyRocks is now pretty much the de facto standard for large data sets in TileDB. I'm sorry, large data sets in MariaDB. Since TokenDB has been deprecated and being removed from MariaDB, MyRocks is kind of the de facto standard to compare to. So some of the advantages of MyTile is we have cloud native support again, so you store that data on S3 or blob stores. There's also large interoperability with TileDB integrations or APIs. So that means that, with MyRocks, it's based off RocksDB, but there are some semantics that are involved there, so you can't quite query the underlying RocksDB key value store from outside of MariaDB, or it's not very common to. But with the MyTile, it's the native TileDB format. There's no special format, no semantics, and you can just query that array directly from MyTile or from anywhere outside of MyTile without any problems. There's also some differences in compressors offered between MyRocks and MyTile. We have some additional encoding, such as run length encoding, double delta, and several others. Now, of course, there's some disadvantages too with MyTile. MyRocks is more mature, and it supports additional things in MariaDB for statistics and parameters. MyRocks has a lot of built-in support for things like the performance schema and other statistics in MariaDB. TileDB itself has internal statistics, but not all of those are plugged into the performance schema and things like that. MyRocks also supports MariaDB transactions and checkpoints, where, like we said, MyTile does not, although MyTile does not necessarily have a need for the transactions to get the same level of ACID compliance that MyRocks does. So I'd also like to talk about a couple of use cases of MyTile that we have today. So the first one is we have a customer in the geospatial domain that has AIS location data. That's the lat long and other information about a ship. They store this data in sparse TileDB arrays today. And they have employees that access the data via a number of methods, including from Python directly from MariaDB and from the embedded MariaDB. And the great thing here is the employee can pick the tool they want for the job. From Python, they might be using the embedded MariaDB instance to run SQL queries directly. Maybe they're more comfortable with SQL than they are with Python, or they have a better familiarity with how to use bounding box queries and certain things in SQL, so they're able to do that. Or, also if they're trying to integrate maybe with some sort of mapping software, or maybe Pandas data frames or something else, they can use Python and access the TileDB API directly and use array semantics to access that. But the real power here is that the TileDB array can be accessed by the best tool for the job, or whatever the user is most familiar with, and they're not bound just to the SQL query. If they need a different type of integration, it is available to them. The other use case we want to highlight is a time series data set. So we have a customer that has a common time series data set of stock market and asset trading. They store the data in sparse TileDB arrays, and they use the embedded MariaDB to allow that fast and easy data exploration. So they're able to run queries directly from a Jupyter Notebook or from the laptop to explore the data and make some initial testing of maybe machine learning algorithms or something. Now, for their large jobs, they tend to use Spark or Dask or some other tool to run large distributed queries, which is great because we have the interoperability to do that on the exact same data set. But an interesting note about this customer is they've actually experimented with running distributed SQL queries via a cluster of independent MariaDB servers. So they spun up a handful of MariaDB servers. There's no cluster, no Galera, no communication between them, no replication. And at the application layer, they shard the query ahead of time and issue it to all the MariaDB servers in parallel. And because everything's lock-free, multi-reader, multi-writer support, they can run that computation in a largely distributed manner and then collect the results back at a single client. It's a very interesting use case and kind of shows some of the flexibility offered by MyTile and some of the advanced use cases. And I look forward to working more with that customer and experimenting more with things like Spider to do some of the sharding in a more automated fashion. So besides just our customer use cases, I want to talk a little bit about how we use MyTile internally to TileDB. And to do that, I want to highlight again that at TileDB, we have two different products. We have the TileDB Embedded, which is a fully open source storage library that's built on top of MyTile, and we've talked about here. And we also have TileDB Cloud, which I hinted about before, which is our SaaS offering of a hosted solution where you can do access control and sharing and have hosted notebooks and serverless computations via both serverless user-defined functions in like Python or R, and serverless SQL. And that serverless SQL is powered by MariaDB and the MyTile storage engine. So we run a variety of MariaDB servers in an autoscale cluster in an autoscale manner, and we allow the user to query their data set remotely with simply just the string of the SQL. So here I have a little snippet of Python code where they're going to access this data and perform some sort of aggregation. They just give us the query, and what happens is that string is taken, shipped to MariaDB in our service. We run it, and we return the results directly to the user. It can be returned as a Python, as a Pandas data frame in Python, or as JSON in any other language, or the user has some options depending on what they're trying to do. But the real benefit here is the MyTile storage engine is able to be used in this manner for this serverless SQL integrations that we have. It works, from a client perspective, it's very similar to the embedded offering of MariaDB. They just give a SQL query. They don't worry about running a server and maintaining the server. They're able to access remote data sets simply on MariaDB by issuing the query. The main difference and benefit here with the serverless SQL is you're not pulling the data down to your machine. So if you're on your laptop, you don't have to worry about pulling the data across the internet. You don't have to worry about the memory requirements on your machine. All the resources and connectivity is handled in the TileDB Cloud product itself. So that's it for the introduction to MyTile here today. I thank everyone for their time. We look forward to continuing to work on MyTile, to upstream it to MariaDB itself, and work with the wonderful folks at MariaDB to continue investing and promoting in MyTile. We hope that you found some of the use cases interesting, and we're very happy to answer any questions and to discuss more about MyTile and TileDB in general. Feel free to reach out to us at any of the contact information you see on the screen. We look forward to talking about MyTile more and discussing in detail with everyone here today. Thank you again.
Thank you, Seth Shelnut in Boston, and great to have you here live without any need for a proxy. I see you are somewhere between Sanya Bielkin and Valery Kravchuk on the beard level.
Yes, thank you for having me here. And yes, I'm very respectful of some of the beards I've seen so far today.
Good. So I've been asking around, when understanding something like MyTile and TileDB, you have to have some comparison points. And when I asked around, people were comparing TileDB to Parquet and MyTile somehow to the new S3 storage engine at MariaDB. So how do you compare TileDB to Parquet and MyTile to S3?
Well, this is a great question. And I think Parquet is probably one of the most common formats that we get compared against. But I think to start answering that, it highlights the fact that Parquet is just a format. Parquet is an open source project from Apache, for those who might not be familiar, and it's a format for a file, which is commonly used in Spark with Databricks, and now today in things like Delta Lake, also used in Pandas, and it's quite popular, especially in the Apache ecosystem. But one of the main limitations of Parquet is that it's simply a format. There's no storage library associated with it. Like with TileDB, we have a common embeddable C++ library that implements a lot of the features. With Parquet, you get a decent format. Let's not say that it's not decent. It's pretty decent. It does a lot of great things. But the limitations really come into play when the fact that, first off, it's a one-dimensional format. So you can sort your data on one column, but you don't get to sort it across multiple columns. Like TileDB is multidimensional. So if you have 2 or 3 fields that you want the index and sort to be on, TileDB natively handles that. With Parquet, you start implementing things at the application level to handle that. Sharding and partitioning, like in Spark or PrestoDB, where there may or may not be compatibility because it's at the application layer. And we see things like Delta Lake being introduced for Parquet to address some of the shortfalls that Parquet has. But again, as soon as you start introducing these additional applications on top, your compatibility drastically reduces, right? Delta Lake is a great piece of software from Databricks. However, it locks you into that Spark type ecosystem. So if you're trying to use it from outside of that, maybe PrestoDB, or again, like here, we have a MariaDB integration with MyTile. you lose a lot of that interoperability and that functionality. And of course, there's additional complexity and overhead when you start introducing things like Delta Lake on top of Parquet. That's another service you have to manage. More engineering resources have to go into managing that software. And really, you know, Delta Lake and Iceberg and Hootie and a lot of these things that start building on top of Parquet are there to address shortcomings in the Parquet format itself. TileDB from the start addresses most of these shortcomings. You know, as we saw in my presentation, we have an MVCC design that works with object stores, that handles updates, that lets you do time traveling. You know, it's conflict free. And, you know, with this multi-reader, multi-writer model that we can support, we really don't need all of these additional applications and libraries and packages that people put on top of Parquet to gain the same level of compatibility. And we're also able to maintain a large, you know, list of integrations, including things like MariaDB, which, you know, Parquet has not quite got to yet. And it's not really on the radar of the Apache Foundation. So we're able to maintain this large list of integrations because we have one, you know, beautifully written standard C++ library with all the bells and whistles self-contained.
Yeah, so that was TileDB, but was my comparison with the S3 storage engine of MariaDB, was that somehow relevant?
Yes. So most certainly. So the S3 storage engine that has come about in 10.5 with MariaDB is, you know, primarily focused on long-term archival of tables. You know, it's a modification of the area storage engine for supporting, you know, the archival to cloud object stores with S3 today, and I'm sure additional ones in the future as the demand grows. With MyTile, you know, it's a little bit different because we do support read and write operations on the cloud object stores. So the goal is really for real-time usage of the cloud object stores, you know, run analytical queries live, not just for archival purposes. Now, you know, there's a little bit of difference though. You know, the S3, again, the S3 storage engine is targeted toward archival. So, you know, you want that long-term storage. S3 is MyTile is designed for that more interactive queries, right? You know, not necessarily for archival, although, you know, of course, any table can be archived by just not using it. But we're designed more for real-time usage. And also, I think it's important to say too that with MyTile, we're really focused on that multi-reader, multi-writer mode, right? You can put the data in a cloud object store and you can access it from MariaDB, one or more instances. As I mentioned, you know, we have a customer that's tested out multiple concurrent instances for some sort of sharding, or other APIs. You know, maybe you do want a Spark job at the same time you got MariaDB, because there are use cases for some different integrations there.
So when it comes to the integration with the MariaDB, do you in MyTile also support things like secondary indexes?
Yeah, so that's a great question. So the TileDB format itself today only supports one indexing, so to speak. Certain fields, you mark them as dimensions in TileDB is what we call them. And those are going to be the dimensions of your multidimensional array, right? So you might have 2 or 3 fields if you want a 3-dimensional array. For example, video is an easy one to talk about, right? You have X, Y coordinates plus time. That's a 3-dimensional array. Or you might have map data, right? Lat long coordinates that are there. You can add, we convert those dimensions into a primary key or just an index if duplicity is allowed in MyTile. But we don't support the secondary indexes in the same way that, you know, other databases, you can create these secondary indexing on the database. Instead, what we do to gain additional performance is we do the condition pushdown. So, you know, MariaDB is fantastic, and it supports a lot of conditional pushdowns of different predicates and operations and functions. In fact, with the column store being upstream, the condition pushdown support has exploded, and now you can do pretty much anything under the sun, which is fantastic, because in MyTile, there's certain types of queries that we can intercept and run on that the query optimizer might not traditionally think can be used by an index because of how it is. So for instance, most of the optimizer most of the time will prefer to use indexes where with a matching prefix, right? If you have 3 columns, you need to have the columns in the proper order to be able to use that index. With TileDB, although that gives you the optimal performance to do it in the right order, we definitely support pushdown instead of full table scans of partial index searches, even if they're in the wrong order. So we use that condition pushdown to intercept that.
So I warn you, you have less than a minute to answer my last question, but it is I'm intrigued by this condition push down thing. So you think that in a way, condition push down is a substitute for secondary indexes?
Yes, it most certainly is in this case. Now we are looking to add some sort of secondary indexing support, especially for the non-clustered columns in the future. But the condition pushdown lets us intercept things that TileDB can do in a powerful way that other storage engines might not necessarily do, because TileDB, again, it's designed outside of MariaDB, right? We support many integrations. It's a self-contained storage library. We have a lot of pushdown support, different type of expression support. And so that condition pushdown allows us as a storage engine ourselves to intercept what we know we can do better.
Cool. I think those are great. I'm sorry to have to interrupt you, but those are great concluding words. So thank you for a great presentation, Maintal. Thank you, Seth Shelnut.
Thank you so much.
Our next presenter is Ram Sajja. It's about IT operations on Azure with MariaDB.
Hello, this is Ram Sajja, Global Head of Engineering and Service Delivery at Cloud4C. Today, I'm excited to take you through the journey of how we use MariaDB in our organization, and hope you'll find this session useful for your own application of MariaDB within your applications and your business requirements that you might have. So thank you for joining this session. I'll take you through a very brief overview of our company. As I mentioned, Cloud4C is born in the cloud organization. We specialize in cloud solutions, and that's all we do is cloud applications, and we provide our services to our customers at the application layer, giving SLAs at the application layer instead of the individual infrastructure or platform as a service level that is commonly offered everywhere. We're basically an end-to-end managed services company. We manage over 40,000 virtual machines, 2,000 terabytes of HANA Enterprise Cloud. We specialize in many database areas. MariaDB is our area of specialization. Oracle, other commonly used platforms like CosmoDB, Postgre, all these platforms are fully supported by our database services program. We have over 2,000 experts that work exclusively in the cloud environment. 600 plus engineers are certified in Azure technologies, and we bring to the market a wide variety of skill sets with an exclusive team that we have in multiple locations. Our service offerings are quite well differentiated because we're a cloud native company. All of our managed services are offered with cloud in mind, hyperscalers in mind. And we are a unique player in this pretty crowded market where you run into a lot of traditional SIs and IT service providers. You also have some smaller entities that get into very niche areas. We kind of fit in the middle. It's a combination of what a traditional SI would offer and what a small MSP would offer to you in a niche area. So basically, our services are fine-tuned to provide you very custom services for your business needs, while focusing on the intricacies of the technology so that you can focus on your business needs. We have over 750 public cloud experts in Azure as well as AWS combined. As I mentioned earlier, over 2,000 cloud experts specializing in hyperscalers, very well versed with the standard industry processes and methodologies like ITIL, COBIT. We're a very security-focused organization as we handle a large amount of data. And I'll walk you through some of those specializations that we have. We are very focused on industry and country-level compliance requirements that customers need. And all of our solutions, whether it is a database solution or a platform as a service for your applications, is all driven through our compliance program. And if there is something that you don't find here, we probably have it. We just, and if you don't have one, we'll get that. Basically, we embarked on the journey of selecting a database platform for our internal purposes initially. So we chose MariaDB, and I'll walk you through why we have selected MariaDB as our database platform of choice. We looked at some of the key benefits MariaDB brings to us. First of all, open source is very important for us, not purely from a licensing standpoint, but the sheer ability of thousands of engineers being able to continuously innovate and keep the product up to date and come up with new solutions that our customers traditionally need, and our own very complex system that we have built for providing the managed services that we deliver using our platform. We're a platform-based managed services provider, so platform is everything for us, and we heavily rely on our CRM platform and other closely integrated platforms that we have in-house. So open source was very important so that we have the ability to change the system to our needs. JSON APIs are very key because our core platform, we have a self-healing operations platform that needs to be integrated with a variety of different platforms to bring services to our customers. And these APIs are a very key part of what we need to do. Parallel data replication is very important from a scaling standpoint as well as availability requirements that we have. And the ability to store in multiple storage engines like InnoDB, MyDocs, Spider, whatever you may have, is very important. We have a very big data analytics practice, and some of the column store features that are offered by MariaDB and the analytics solutions that are easily integrated with the help of MariaDB technologies have also been a very key player in our selection of the product. And the sheer fact that MariaDB can be easily deployed in a cloud platform and managed through a standard DevOps pipeline has been a very key deciding factor for us in selecting the database for our platform. Let me walk you through a little bit of our implementation of our CRM platform, which is totally built on the MariaDB database platform. So our CRM is about a terabyte and constantly growing. And if you take all the archiving and all the historical data and all that we do offline, which is also in MariaDB, it's quite large. So to handle such large database as well as the concurrent transactions that we get every day with our platform and handling our customers over 2,500 plus that have direct access to this platform, the database had to be built in a very scalable way. So we've created a MariaDB cluster, which is the heart of our processing engine. And as I mentioned, we do need historical data. So while the online transactions that take place need to be instantaneous in terms of how the service levels are experienced by our customers, we also need to have historical data for reporting and analytics perspective. And also when we talk about self-healing operations, these historical events are a key deciding factor in what automation can take place to handle any problems that we see in our day-to-day operations as we offer the infrastructure as services or platform as services. And in this regard, we have a 3-node cluster on the main transaction processing side, and we have a 2-node cluster on the archival side of the house. We've also set up a disaster recovery environment where there's a 2-node cluster that is constantly in sync with the primary cluster. We cater to about 2,500 plus customers with 1 million transactions each day going in and out and more. And basically, these transactions are not lightweight transactions because of any traditional CRM platform. There is all kinds of data coming in and going out, whether it is objects, such as documents that are uploaded, screenshots, things of that nature, emails, chat conversations, all kinds of structured and unstructured data flowing through the system. And the system itself has several portals on top of it with various web technologies built on it. And these platforms, again, are accessed through the internet as a web interface, so the response time has to be very quick. And MariaDB, we have used some interesting features that are available in MariaDB to handle such transactions that come through the internet. In addition to that, the platform is also integrated to our monitoring systems as well as third-party tools that we use internally. And as you can imagine, with the monitoring system, there cannot be any lag in terms of when an alert is triggered from one of the systems and the time it takes to reach the CRM platform and ultimately customer being informed. All this needs to happen within a matter of seconds and not minutes. And with the volume of this traffic that comes through, there is a very complex engine built that understands this data, that understands these alerts that are coming in. The the actions that need to be taken automatically or the information that needs to flow. So all this is seamlessly integrated and works very smoothly through the CRM platform, thanks to the MariaDB scalability and performance benefits that the database comes out of the box with. We also offer to our customers database recovery services, DR services, and many other offerings that are traditionally required, so that you have a point from where you can get your data back in case if there is a primary disaster at the primary site. So in those solutions as well, we've got some very good automation built in, where the customers don't have to really reinvent the wheel in setting up their DR environment. So the DR as a service for MariaDB is extensively used by our customers with our service offering as well. So to kind of point to you some of the features that we've used and we thoroughly enjoy is one of the key features that we use in MariaDB is the in-memory tables feature, where the alerts that are coming in, as I mentioned, in large volumes, if we were to use a traditional structured tables that are stored on a disk, it would have a lag. So we started using memory tables in there, and these complex logic engines work on top of these memory tables. They look for any similar alerts, any previously existing tickets that we may have to look into, and bring all that information together, collate it automatically, come up with some intelligence, and provide necessary actions that an engineer needs to either take manually, or that can be auto-remediated using past history. So this is all tied into our knowledge management database, and the knowledge management database also works on a MariaDB. So the whole access of this information, the analytics part of it, the analysis that is done within our custom engines is all instantaneous, and the actions that need to be taken are also done at a very fast pace. So the SLAs that we commit to some of our customers is so low in terms of turnaround time that this kind of efficiency is very much required. There are some challenges in managing in-memory tables, obviously. And so the important aspect of it is to make sure that in-memory tables are sized right. And you're constantly monitoring these tables so that you're not running out of memory, or the row count goes so high that it becomes inefficient, and so on and so forth. But that part can be easily automated and provide very efficient transactions to our customers. The other key feature that we really like about MariaDB is the security aspect of it. So in this day and age, with all the compliance requirements that we have and the threats that are out there in the world, encryption is a very important aspect of any database that you choose. So encryption at rest is a key aspect of any database of your choice. MariaDB out of the box offers a variety of options on how you encrypt your data, whether it is at rest or in transit. If you're doing it at rest, we can use the native tablespace encryption that is available through some of the storage options that MariaDB gives you. And there are multiple storage options that you can choose. And also, when it is in transit, you can use SSL to have your connections encrypted end-to-end. That is a very key feature that you must look for in any database. While most databases offer this feature, MariaDB is very efficient in handling this kind of transactions. Also, an added advantage with MariaDB is you have a database proxy that you could use. You can use MariaDB's option of MaxScale as a database firewall, so that you can look at the users that are coming in, whether it is at a user level that you want to restrict, or a query level, or harmful queries that could be executing, or data being taken out. There's a lot of customization that you can do using the built-in database proxies, so that you don't have to go invest in another product to try and achieve the same thing. So these are very, very important, because we're driven by compliances. We have to have these features in the database, so MariaDB was able to serve these needs. The other important aspect when you're serving such a large group of customers, and data segregation is a must, multi-tenancy is a must, and role-based access is a very key aspect of it. So out of the box, MariaDB role-based access control is very cool, and offers a lot of flexibility for our needs. So we were able to use the out-of-box role-based access control from MariaDB and make our DBA life a lot easier in managing the privileges that are needed to be given to the customers. When it comes to basically encrypting data, that is also quite easy if you're trying to use the MariaDB access management that is built in. Not only that, there is a lot of flexibility with the security plugins that are available from MariaDB so that you can easily integrate it with your application or third-party tools that you might have and meet your compliance standards. So this was a very key feature that we really like and use it every day. The other aspect of it is how do you prevent threats? There's threats all over the place, and with all the configuration settings that you might do, have a firewalls in between and even web application firewalls and so on and so forth, still the threats exist. So some native threat prevention is an absolute must. And the features that come out of the box with MariaDB from a defense perspective or threat detection perspective and stop it immediately at the source of it is a very important feature. The ability to handle denial of service attacks or overloading of an application, SQL Server injection attacks, things of that nature are very, very important when you're running a database in a publicly exposed internet. Now, the database may not be exposed directly, but you do have an application exposure, and that in itself opens up a whole world of threats out there that you have to handle. So this is a very important aspect of it that we've looked at when we were picking MariaDB, and our journey has been very, very good with all the features that have been available over the years. So as we look at these options that are going into the future, so we did an analysis and said, okay, we've been running this MariaDB on-prem. What other options are available? So there comes Azure database services for open source, variety of open source databases. Azure is pretty popular with MariaDB in terms of the implementation there. They're strongly encouraging migrations to Azure platform using their native version of how they deployed MariaDB. And there are multiple options that we can go with. So if you look at this picture, we started with an on-prem version of MariaDB, worked very well for us. As we grew in size and as well needs increased and there were better ways of doing this same implementation on Azure, we initially looked at using Azure platform as an infrastructure. So that basically gets you out of the hardware maintenance mode, the data center management stuff, and virtualization that's basically handled for you. And you basically take you're basically managing operating system and that. That was pretty good. It's pretty efficient, helps you a lot. So then we started looking into it and said, why not use it as a service? So we looked at the Azure database options where they do offer MariaDB as a native offering. And look at the stack. Now you're able to go all the way up to the database layer, and now you don't have to worry about how the database works itself. You kind of focus your energies on your application and whatever you need to do from a business analytics perspective and so on. So we have migrated from our on-prem version to the Azure database platform as a service model, where the efficiencies are incredible. I don't have to worry about disaster recovery. I don't have to worry about scalability. All those are baked in, and I just consume the database services that come out of the Azure database. So when we are trying to do this, we were, well, obviously you have to explain to your management why you're trying to go to Azure when your system is working perfectly fine on-prem. Well, if you look at it as from a different, you have to look at it from various angles. Basically, look at the database management support. Now I can have the same database administrators who are typically handling a lot of backup related issues or performance tuning or scaling issues and things of that nature have been freed up to more focus on the business needs and focus on the product that we have internally. And ease of management when it comes to handling the same MariaDB on Azure, it is just incredible. Time to market and cost effectiveness of deploying it on Azure instead of running it on-prem was a very key factor for us to go with this direction. Third-party integrations come built in with Azure. It's easy for us to work with our vendors as well, since they also use a similar platform on Azure. Monitoring and uptime has not been a worry for us, since that is all baked into the service levels with Azure. data security and compliance is also built into the Azure platform as well. So a lot of things that you would typically worry about as a database administrator or an application developer on MariaDB have really been built into the platform that you don't have to worry about, bringing you a lot of efficiencies on the business side of the house. So the other aspects that we were looking at it is, well, are there any native tools available, elasticity options, any migration support, because when you're trying to take it from an on-prem situation to Azure, that in itself could take some time. So any help in that area, any manual work that can be automated, integration with third-party tools is a key aspect for everybody, and most importantly, data security. All these have been thought through and addressed by Azure Database Services. And it comes right out of the box, and we're able to take advantage of these options that are readily available. So when we deployed it on Azure, it was a very simple transition for us. All we had to do was replace our bottom layer from our traditional infrastructure and replace it with the Azure stack. And basically, all the monitoring, data high availability, the platform itself, the data security, disaster recovery, everything comes built in for us. And we didn't have to change a whole lot of code or anything like that. And the migration was very, very quick and smooth. And basically, we even used the traditional tools that come with Azure migration services to make this transition even smoother. Our user community never even felt the migration was actually taking place because it was done so transparent to them. They couldn't even see where the platform was coming from, basically because they're just using the web URL and the URL remains the same. Now, how do you work from your workload from a on-prem situation to Azure? Well, there are a couple of options. So initially, when we were doing the testing and checking and seeing if the platform would work, we did an offline version of it because our development QA systems can be taken offline during off-business hours. So we did an offline proof of concept migration to see if the platform would scale and provide the services that we were providing from an on-prem situation. That worked very well, and I would recommend that from a proof of concept perspective. But when it comes to migrating your production workloads, instead of taking a huge downtime, we recommend going with the Azure Database Migration Service, which can do an online migration of it. So you keep your database from on-prem in sync with your Azure database for a while, and on the cutover date, you take a small or almost near zero downtime to make the switch happen, and the users won't know the difference. Now, as you get through this process and want to get into an online migration model, there are a few things that you have to do. You have to prepare your source instances for migration. You have to check your workload dependencies, any replication details that you need to worry about, resource requirements, what is the sizing, things of that nature. You have to create an appropriate size on Azure as well, so that your performance stays intact. Any schema creation that you need to do with a dump for some of the more offline tables, or in other words, more static tables. And understanding how Azure DMS tool works to get your near zero downtime. Worry about your connectivity and security aspects of it, get your compliance audits done, and so on and so forth. And once you've accomplished these pre-activity tasks and you've set up all these environments appropriately, the post-deployment testing and release is the last thing that you should not forget and accomplish immediately after your cutover is done. So what is next for us from Cloud4C, and what are we trying to do with MariaDB? We already have DevOps as a service that we offer to our customers. And as part of this offering, we're also bringing MariaDB that is available through Azure Database Services as part of the DevOps pipeline. So in other words, we're basically making the whole journey of application development all the way, including any database related activities, as a seamless pipeline, which you can deploy, create, destroy, do whatever that is required in your daily operations, more in an automated way through native Azure DevOps tools, or a custom pipeline that you might already have that can be embedded into the Azure DevOps pipeline, and manage your MariaDB instances that way, so that you can further automate the database administration side of the house and cannot worry about databases at all, and really focus on the business requirements and the business logic that you have, and spend more time supporting the customers that you have to deal with, instead of sitting there in the back room trying to code or trying to debug a database problem or trying to just migrate code, which is just a waste of time. And in this regard, Cloud4C brings to you a lot of offerings. I really welcome you to reach out to us. If you're looking for any remote database administration services, migration services to Azure, any architectural related help that you might need. If you're purely looking from a reduction of cost standpoint, if you're interested in any improvement on your best practices that you need somebody to come in and look at it, any analysis assessments that you need, security hardening, whatever the case may be, we have a full stack of end-to-end managed services that we can provide you in this space. And we're really excited to talk to you about your business needs and what we may be able to help you with. I really appreciate you taking the time. I know we have a very short window in this conference. I hope you're enjoying the conference very well, as much as I am. And look forward to any questions that you may have. And with that, thank you very much for your time. I appreciate it very much.
Thank you, Ramsajan. Great to have you with us live here from Hyderabad in India.
Thank you, Alexander. How are you?
Yep, doing fine. So, thinking back at your presentation and Azure, MariaDB, how can you tell us a bit about the journey, how you ended up with Azure?
We are actually Microsoft partners, and so there were some discussions initially where Microsoft was encouraging on-prem solutions to move to Azure. So we looked at the various options that were available there and our own interest in trying to get into a hyperscaler situation where we don't have to worry about the underlying infrastructure components. We're an infrastructure company by definition, but still the added advantage of relying on somebody else to do that for us was really an interesting piece for us. So we did that initially as a proof of concept for our partnership. It was so successful that we decided to stay on and run our live workloads there. So very exciting journey all along.
Good, good, good. So a very good rational reason why you picked Azure. So did you have, I mean, you had evidently a good on-prem solution, and people say, why change a working system? Well, you did explain why you wanted to change, because you want to rely on infrastructure by others. But what were your practical challenges when doing that move from on-prem to the cloud?
So when we own the infrastructure and when we set up everything internally, we have a lot of flexibility in how we do things, how we secure our database platform and the tools that we deploy. We could be a little bit more lazy, in other words, in terms of our application design and how we use it. And so when you move to a hyperscaler, even with a partnership, there's always the billing side of things. So we have to be more efficient and consume our resources on the hyperscaler more effectively. So with the very competitive pricing that we get with Azure, still billing is something that we needed to optimize on. So those were some of the things that we paid attention to and made sure that we're not running up the bills unnecessarily by optimizing how we are utilizing the compute that we have taken and the storage we have taken on Azure. It's not the auto cleaning jobs that we need to have, the archiving of data, because we have a large amount of data that goes in and out and that needs to be maintained, has been very well optimized. So some of the things were to do with how do we manage our data better, how do we optimize our system so that the compute cycles are not extraordinary, things of that nature were the things that we looked at. But other than that, we didn't have to change anything on the application side. From a security standpoint, we had adopt the Azure-based security, which is very robust. So that was it, and not a whole lot of change there.
Right. So you mentioned that it might have some implication for exactly how the billing looks like, and that triggers a bell in my head. What about performance? So did you do anything about performance influences, and also what was the end outcome when it comes to performance from the end user perspective?
So performance from a backend standpoint, we didn't have to do a whole lot. We actually gained some because we were moving from a certain platform in-house to the more newer platform on Azure. So that was an added advantage. So it was better from a backend standpoint, purely from numbers. However, user experience is the key. Now there also we saw quite a bit of benefit because our user community is distributed globally. And when we are using the applications in such a manner where we're not sitting in one or two buildings where you can optimize the network and get your optimal performance, that's a different side of the house. We started there a long time back. But those days are gone. So now it is very widely distributed world. So we had to, so the Azure platform gave us a very good performance from the user standpoint as well, because we get to use a lot of Azure tools to provide that end user performance better.
That sounds great. And I think those are great concluding words for your presentation on MariaDB combined with Azure. So thank you, Ramsaja.
Thank you, everybody. Thank you for taking the time to spend with me.
Sure. So that was it for today. I hope you liked it. If you did, feel free to share it on social media, LinkedIn, Twitter, hashtag MariaDB Serverfest. And tomorrow we'll continue. I would say same time, same channel, but the channel won't be the same. There's a new YouTube link, and you'll find it on mariadb.org/fest2020. So see you tomorrow.